Check, 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 check. Okay. Stand right here.
Either at the podium or in the inside.
Or the inside.
Stop.
Okay, so why not on this side?
Because as far as the camera shot.
Oh, the camera. Okay, okay. Yeah. Okay.
But they need to stay within pretty close to the microphone to be able to be heard.
Yeah, you don't need to touch the microphone at all. We've already tested it and everything at a good level. You can stand normal. Secure.
Okay. And then-
Maybe a little bit lower for that. They're always gonna need to be able to.
You ready? Okay, I think we're ready to get started. Okay, good morning, everyone, and welcome to the 5th Annual Texas Plastic Pollution Symposium. My name is Lisa Marshall, and I am the Program Manager and Director of the Galveston Bay Estuary Program. With Houston being the largest city in Texas and the fourth largest city in the United States. And with over 700 bays and square miles of bays and bayous, we have a lot of issues with trash and plastic pollution. So we are very excited to be hosting the symposium this year. The last time we hosted it was in 2019. We're very excited that it's back here in the Houston-Galveston area. I just want to give a couple of thank yous. First of all, to the University of Houston, Clear Lake for hosting us. This is a great venue. The theater's perfect size for all of us. We've got lots of different areas downstairs for all of us to mingle and eat and do everything. So it's a great venue. So we really appreciate University of Houston Clear Lake for hosting us. Also want to thank the planning committee for all of their time and effort in coordinating and organizing the symposium. They put a lot of effort into it, and I think it's going to be great day. Lastly, I want to thank Jace and the Nerdle Patrol for their support. Without them and their support from the Matagorda Bay Mitigation Trust, we couldn't have this as a free event for all of you. So thank you to them. Just a couple of housekeeping things. The bathrooms, there's bathrooms on each side. There's also a water bottle, water station for your water bottles. They're in the garden room down by where you registered. There are the posters. Make sure if you haven't set up your poster yet that you do that during the next break so that we have it during lunchtime when we have the actual poster session. And I think the only other thing is I was going to make one other announcement. A lot of you are involved with the or have attended the Trash Summit. The Partners for Litter Prevention has a trash summit every May. Just want to announce that we will not be having one this year, unfortunately, but we are hoping to have an event in the fall. So please, if you're interested in getting information and being on the email list for that, there's a Black Cat GIS table, go down there and get your name on the email list so that you can find out all the events going on for that, as well as all the other vendors. Please visit all the vendors. They have some really great information and swag out there. So with that, I am going to hand it over to Jace, who's going to make a few other announcements and then get us started with our presentations. Thank you.
Okay, thanks everybody for coming out. I do just have a couple things. We do have about 68 people registered for Zoom. So this is kind of a hybrid meeting, although if you're on Zoom, you can't ask questions or any kind of interactive, but you can hear what we're doing. So that's important for speakers to know, because if you're not talking into this microphone, then the people over Zoom cannot hear you. So try to speak into the microphone. We do have 4 different moderators today. I'm moderating the first session, and that's because I'm presenting. So I want to be able to present for as long as I want to, you know. But we also have a microphone over there. So if an audience member asks a question, the moderator will repeat the question so that people online can hear. For presenters, there are 2 presenters that have not turned in their presentation yet. If you're one of those, there's one at 11 a.m. and there's another one this afternoon, like at 4 p.m. or something like that. If you have not turned in your presentation, do that at the break that's coming up. Look for Matt. He's by the registration table and he's got his computer and he can upload it there. For presenters, you have 12 minutes to present. We do have a timer. And once they stand up, you're basically out of time, or you'll have 1 minute left or something like that. And then there's 3 minutes for questions. And so total, you have 15 minutes. Let's see. Oh, I want to thank the judges. What's really cool about this meeting is that students get a chance to present the research that they're doing. And we get an opportunity to be able to reward them. And so there are judges that are making that possible. And so for both oral presentations, there's 3 awards for the best oral presentations. And then for the posters session, there's also 3 awards then. Those will be given at 5 p.m. If you are a judge, turn in all your judging stuff at the last break, which is around 2:45. and Lisa will be out there. Is Lisa might still be out at the registration desk, but she'll be by the registration desk. Please turn in your judging forms there. That way we can work them up and get the awards ready. And thanks to the Coastal Bend Bays and Estuaries program for providing the awards. They're actually like gift cards, not gift cards. They're cash cards or whatever you call them. Okay. So with that, I'll go ahead and start my Oh, no. One last thing. Stenny printed this up for me. So we have 252 people in person that are registered. We have 68 that are virtual, 141 different organizations. So that's pretty amazing, that many people involved. And you can see based on this up here of how many groups were together and just kind of putting this thing on, there's a lot of logistics that go into something like this. 4 different countries, and a lot of state, local agencies, NGOs, foreign and national state nonprofits, colleges, universities, industry, and private sector small business. So this is a great turnout, and I really appreciate everybody coming out and being a part of this. So if we could get the first presentation up and going, I'll spend the next 45 minutes talking about that. So normally I give a presentation on Nurdle Patrol, and what we're kind of doing in the US and globally. But this time I'm going to talk specifically about what we're doing down in Mexico. So back about a year and a half ago, we were able to get a grant from the NOAA Marine Debris Program. And it was about expanding Nurdle Patrol efforts throughout Mexico. And so these are just some of the partners we're working with to be able to make this happen. Of course, we have to have a partner down in Mexico. So we work with the University of Veracruz, Dr. Horacio España, of course, University of Texas Marine Science Institute, the Conrad Blucher Institute, which if y'all have ever been to our website, they're the ones that created the website. And it's not your typical website. It gathers data, standardizes it all, and puts it on a map viewer that people can print up digitally or hard copy. So it's not there's a lot of data that goes into it, and people are always trying to hack into it. So you got to have somebody who knows what they're doing with that one. The NOAA Marine Debris Program and the Matagorda Bay Mitigation Trust. For those of you that don't know what nurdles are, they're the raw material to almost everything plastic. They're little pellets. We are finding them in lakes, on river banks, and on shorelines of the coast. And so in an effort to try to figure out where the hot spots are, maybe try to develop some solutions to this issue through policy, we started this citizen science group up called Nurdle Patrol, going out, looking for 10 minutes, finding how many you find, and go to nurdlepatrol.org, put where you were at and how many nurdles you found. And the reason we're doing this is because we know there are negative impacts to nurdles out in the environment. The biggest impact is probably to wildlife eating these. We know that these absorb harmful chemicals to the outside, so those can also have an impact on wildlife. So these are the reasons we're trying to fix the problem. So our efforts down in Mexico, the first thing that we wanted to do was be able to translate everything to Spanish. So that it's usable to folks down in Mexico. So this is our rack card. We do have a little table downstairs that has all these. Actually, we put together individual nurdle kits, sampling kits for you, and that's one of the bags y'all picked up out there. So if you open up that little purse, it's got this card in there. But we also converted this to Spanish, and we print thousands of these off and send them down to Mexico. But it just describes the 10-minute how to do a survey in 10 minutes. So some of the preliminary stuff we've done, of course, we looked at the toxic release inventory that the EPA keeps to see where plastic manufacturing sites are in the US. And then our partners down in Veracruz have also seen where the plastic manufacturing is going on in Mexico. So that's what these maps are here. And it's very helpful for once the data starts coming in from citizen scientists about concentrations of plastic pellets. it's important to know where the manufacturing sites are. Although we know that from the data that's been gathered, it's not just manufacturing sites that spill these or let them out into the environment. It's also transportation. It's also at the factories that are melting the product down or melting the nurdles down to make them into an actual product. We know it all along the value chain, there are losses, and which are being worked on by industry, which is exciting to see. If you look at this map, this is most of the US and then down in Mexico. And I'm going to zoom in here to just the Gulf of Mexico so you can get an idea of where we have information, what it looks like, and then where we're missing information. And so if you look at the west coast of Florida, you see a lot of greens. There are very few manufacturing in Florida until you get to around Pensacola and the Panhandle. And then as you go further west, you start getting more manufacturing. Well, those colored dots up there are the concentrations of plastic pellets found within a 10-minute period. And so the greens are 0. So even if you go out, you find 0 nurdles, that is data, and that's important information. Now, the warmer the color gets, the higher the concentration of plastic pellets found. And so, 1 to 30 is yellow. And then once you get up to purple, that's over 1,000 nurdles collected in a 10-minute period by hand only. And all these data are standardized to one person for 10 minutes. So you can compare what's going on here to what's going on down in Mexico to what's going on in any part of the world. But you'll notice kind of the big data gap that we have here is the state of Tamaulipas, which is just south of the Texas border down into Mexico. And so we haven't been able to get anyone to sample up there. It's dangerous. The cartel down there, our university says we cannot travel down there. So we are trying to work with, I was just in Mexico City about 4 weeks ago, and we're working with partners with Parlay, the big nonprofit that works globally, and some of their works around plastics in the ocean. And so we're working with them to be able to try to get with turtle patrollers up there to do nurdle patrol. It gets confusing, but they're looking for turtles, and on their breaks, they can look for nurdles. So if you look at Texas, you see a lot of these inland. A lot of these sites or the ones up near Dallas are outside of the fence line of manufacturing, down the creeks of where the manufacturers are, or railroads, or in the lakes. The drinking water lakes is where they're finding some high concentrations up in the Dallas area. But a lot of these others that are inland are along railroads. So there's been over 100 surveys done along railroads. And that's why you'll find them there, because that's the way they transport a lot of these. We're trying to do some similar surveys down in Mexico to see if it's also an issue there. And then Galveston. So where we're located right now is kind of the hot spot for the US. This is where the highest, barring any kind of major spill off of a barge or ship, this is where the hot spot is in the US. And it's also where the most manufacturing for plastic is in the US. So as you can see, there's quite a few purples up in here. A lot of the organizations and individuals in this room have collected this data. This information is being used in a lot of different ways. One of them is, I know the Surfrider Foundation is working with some political folks to author a bill. And you might hear more about that here later today. But the information gathered here is going to try to change policy about the way these are handled and regulated. If you look at Mexico specifically, this is Veracruz. That's kind of where you see the majority of the plastics nurdle surveys found there. The university down there, that's where they have easiest access. This project we are working on down there is trying to get new partners and also send out teacher kits. And so I'll just tell you real quickly about that. Oh, one thing I wanted to show you was that you see these dots that go inland up into the watershed, so up the river. That's very important, because if you don't have that type of information, you might be thinking, oh, it's just coming from ocean currents, which it could be. But once you start moving up into the bays and the rivers and the watersheds and inland, it really gives you a better picture. It's like, okay, there's a source here and we need to investigate that further. Globally, this is kind of the big statistics, and then I'll get into Mexico, but over 7,000 volunteers, over 16,000 surveys have been done. We're working with over over 230 partners right now to make all this stuff happen. So it really is a team effort. And then we've sent out over 1,600 teacher kits. And so in Mexico, you can see the numbers are a lot lower, and that is sort of our idea for this project, is trying to expand and really bring Mexico into the loop on this. So 60 volunteers, 612 surveys in Mexico at 244 sites, and then working with 11 partner organizations and only 6 teacher kits. So if you need no teachers in Mexico, let them know. We have everything in Spanish, and we also have it on our website as well, which is Spanish. So this is a Spanish startup kit. You'll probably heard me talk about these before, but it gives an organization everything they need to be able to start up a Nurdle Patrol citizen science project with no influence from Mission Aransas Reserve or the University of Texas Marine Science Institute. It's made to for an organization to start up their own effort. And so there's glass sampling jars. There's a presentation in there that talks about what nurdles are, why they can impact the environment, and then some of our solutions we're hoping to come up with. Teacher kits, there's 6 sampling jars. Actually, they have nurdles in them, and so the students get into groups of 6. It's interactive, so it teaches them about what nurdles are, how they get into the environment, what the impacts are, and then they develop solutions. And it's by grade level. And all this is also available on the website. But if a teacher wants an actual kit, we can send it to them. And it's all free thanks to the Matagorda Bay Mitigation Trust. We hosted a symposium down in Mexico, and this was in Veracruz in September. There was 26 presentations that were given and about 20 posters. And so we're doing the exact same thing. Coming up here in Ensenada is the next one. It's going to be August 16th to 18th. So if any of y'all are interested in going to Mexico, doing a similar type thing we're doing here, feel free to look this up. They actually have a website. If for some reason you can't find it, send me an email and I'll put you in contact with that. We're also, the nurdles we're collecting down in Mexico, Dr. Jean-Fei Liu here is going through and looking at what type of plastic they are, how old they might be, which you can look at the colors and kind of identify the estimated age of them. And so that's what some of this is here. So these are the sites that we sampled. We did the symposium in September. The day after the symposium, we got in a car and we drove all the way to Campeche, which is, if you just drove straight there, it'd be 20 hours. But we stopped at every accessible point and sampled. And then, so what you see here is site 1 is Veracruz, and then site 15 is Campeche. And so if you look here, these are the number of nurdles found per site is in the gray. So what you notice there is that there's a big reduction in number of nurdles we were finding. And there's a number of reasons for that. And that has to do with ocean currents, has to do with rivers, and that has to do with location of plastic manufacturing sites. And then the bottom one here is kind of the color coding of age of nurdles. And there'll be a paper coming out about this, so y'all can dig into it. Some of the other things is looking at the weathering. And I'm not going to talk too much about this because I think there's a poster out here that has some of this on it. So in the poster session at lunch, y'all can check this out. But there is a way to be able to try to look at the weathering and age of these nurdles as well. Okay, so in Mexico, what are we trying to do? Well, it's basically looking at the policies, what's in place now, where the gaps are, what do we need to do to be able to get Mexico into a position to where they're able to contain their nurdles and not release them. There are some other things here. The website, you go in the right-hand corner. If you go there, it's going to be in English. You can click a drop down, press Spanish, and the whole website goes to Spanish. And so if you're Spanish speaking, that's helpful. And then there's also a Facebook page, Nurdle Patrol Mexico. Feel free to get on there. We also have a Nurdle Patrol that's in English on Facebook as well, if you want to get on that. And then gracias. That's it for me. Do we have time for questions? Yeah, okay, so we can have a couple of questions. No questions? Too early? Okay, so some of y'all have been to my presentations before. I've got some shirts I'm going to throw out. okay, to wake you up. Now, I don't know why y'all are so far up there. Okay, so our next presenter is Emily Cox, and she will be talking about estimating abundance of microplastic in surface waters of the Galveston Bay watershed.
Good morning. My name is Emily Cox. I'm a graduate student here at UHCL. I'm excited to be here today and share with y'all what I've been working on the last couple of years, and that is estimating abundance of microplastics in the Galveston Bay watershed. So we're all really familiar with the plastic pollution problem, and this figure kind of sums it up really well. Of the 8,300 million metric tons of plastic that were produced by 2015, 4,900 million metric tons are ending up in our waterways, environment, and in landfills. Because plastic is made to be non-biodegradable, it needs to be durable for all of its applications. It remains in the environment for centuries, and weather conditions, other mechanical actions will actually break down those larger pieces of plastic debris into progressively smaller and smaller pieces until we're left with microplastics. And those are defined as plastic particles less than 5 millimeters. They can also be manufactured, as we know, as microbeads and nurdles, and Houston actually produces the largest volume of these in the country. And so with all that, we know that there is estimated to be more than 5.25 trillion microplastic particles floating in the world's oceans. Microplastics have been documented in virtually every global environment, from terrestrial, marine, even in places that are considered to be remote, like in the Arctic. But heavily urbanized estuarine ecosystems are especially vulnerable to microplastic pollution, such as Galveston Bay, which supports greater than 50% of the country's petrochemical activity. This figure by Shruti et al. Shows the many anthropogenic pathways by which microplastics are entering the Gulf of Mexico. So especially with recreational activities like tourism and fishing, industrial activities like shipping and manufacturing are inputting a lot of microplastics into our waterways. And also wastewater treatment plant effluent and stormwater runoff from urban areas and other tributaries, like they found with USGS, are also big inputs of concern of microplastics. So with all of this knowledge and knowing that Texas has some of the most polluted waterways in the country, the microplastic problem really isn't understood in Galveston Bay. So we're hoping to kind of understand that problem and sort of figure out a baseline of what the microplastic pollution is like in Galveston Bay for continuous monitoring. So what I'm presenting to you today is part of a larger study that we've been working on that actually includes collecting surface water samples at our bay sites using a Houston net. And we also collected sediment sites at all of our bay sites and shoreline sites. Also, our study partners at Turtle Island Restoration Network have been really focused on the citizen science outreach and education objectives. But today, I'm not going to talk to you about that. I'm going to talk to you about our water grab samples that we took at our shoreline versus our open bay sites. To get a good idea of the distribution of microplastics throughout the bay, we selected 5 bay sites and 5 shoreline sites. The bay sites here are these little pink circles, and they were accessed by vessel. Our shoreline sites are these little yellow squares, and they were in intertidal zones. We tried to co-locate our shoreline and bay sites as much as possible for a little bit of comparability there, but you can see that our sites run along the Houston Ship Channel here from Bolivar all the way up to the Houston Ship Channel at Morgan's Point. And we have one site out here in Trinity Bay that's more freshwater influenced and kind of less directly affected by that heavy industrial activity. And all of our sites are heavily affected by recreational activity as well as manufacturing and industrial activity. So we visited each of our sites twice for 2 sampling events, one in March of 2022 in the spring, one in the summer in September 2022, and we collected 3 replicate 1-liter surface water grabs at each site and each event, so we ended up with 60 samples. The procedures we followed are similar to those that have been used in the Gulf of Mexico for other citizen science microplastics monitoring studies. So we followed these same procedures to try to get comparability between studies, because as we know, it's really hard to compare microplastic studies right now. Also at each of our sites, we used a multi-parameter sonde to collect bottom and surface parameters like dissolved oxygen, salinity. We used a Secchi tube to collect turbidity readings, and we also took some categorical measurements of wind and water conditions and other parameters like days since last significant rainfall. We vacuum filtered our samples in our lab just right upstairs from here, and we used a plumbed vacuum system and a 0.45 micron filter with our filtration apparatus. Our samples were able to filter pretty quickly, so long as there wasn't a lot of suspended particulate matter in them, usually within a few minutes. If they had a lot of sediment or other particulate matter, they would start to clog the filter, and we'd need to change this out a few times during the filtration process, so that some of our samples actually ended up with 3 or 4 filters to later examine. The filters needed to dry before we examined them under the microscope, but as you can see in this picture on the left, they would start to kind of curl as they dried, and so we would actually glue them down directly to the Petri dish for easier examination with the microscope. We categorized our microplastics that we found into 5 categories: fragments, fibers, film, microbeads, and nurdles. Fragments, we're looking for pieces that look as if they had been fragmented off of a larger piece of plastic. And they had varying sizes and shapes and a lot of varying colors. We had to be careful here, though, to not confuse them with salt and sand grains, because those were also really abundant on our filters. Fibers were thin threads, basically, and red and blue were kind of the most frequent colors that we would encounter there. What we're looking for with fibers is to make sure that there are no organic or cellular structures, so we're not counting something that's not a plastic. For example, this little looks like a critter leg right there on the right. That would not be counted as a microplastic. Film pieces were pretty difficult to identify just because, as you can see on the left, they're really hard to even see on the screen. And copepods, which were also really abundant, could sometimes be confused for those. If a fragment was perfectly spherical, we could count it as a microbead. We, again, didn't encounter these very often, but when we did, they looked a lot like that picture on the left. Small little black round microbeads could often be confused for diatoms, which are also perfectly spherical. And a test we would use for that would be to poke the item, and if it were to shatter, we don't count it as a microplastic. That was a nice little trick that we could use across all of our categories. And of course, there's our nurdles. Ultimately, we try to use our best judgment. Identifying microplastics with a microscope is really challenging, has its challenges. So if we were unsure that we weren't identifying enough plastic characteristics, we would not count the item and we would move on. So here's some of what we found. Our shoreline sites tended to have more microplastics. They accounted for 57% of all the microplastics that we counted. Fragments were the most abundant category, counted for 66% of everything we counted, and fibers were the next most abundant at 30% of what we counted. We didn't find any nurdles in our water grab samples, but I will say that we've been seeing them plenty in our Newston tow samples and in our sediment samples. I just unfortunately don't have enough data to share with you on that just yet. This shows the distribution of the microplastics by site and also proportionally by category. The size of the pie chart is relative to the number of microplastics we caught or we counted at each site for March and for September. Again, you can see this dark purple color representing fragments is the most abundant. The kind of lighter blue or the darker blue is representative of fibers, and they were the next most abundant. I found it interesting that the composition seemed to change between sampling events at some sites. So especially if you look at our B2 channel site at Morgan's Point up there, in March, it was predominantly fragments, and in September, predominantly fibers. But overall, what we're seeing is that way more microplastics were counted in September than we counted in March. And we want to know why that might have been. When we plot our total microplastics with the days since last significant rainfall, we kind of see a trend of, with more recent rainfall, as you can see here in September, we visited all of our sites within 12 days of the most recent rainfall. So we saw many more microplastics at these sites in September. In March, it had been anywhere between 28 to 41 days since rainfall at our sites. So we're seeing less microplastics. That similar trend you can see with the SECI and total microplastics plot, because generally with more rainfall, there's more turbidity in the waters. And as you see with higher turbidity, there's higher microplastics and it goes down as the water kind of clears up. So we can sort of assume, or what we're kind of think that we're seeing is that maybe microplastics are accumulating on shorelines, and with rainfall and runoff from all these tributaries, they're entering the surface waters in Galveston. So the things that we have seen so far, that fragments and fibers tend to be the most abundant categories of particles, that more microplastics were collected with rainfall at our sites, which is a little different from what USGS found. And also that microplastics accumulate on shorelines. These are things that have been seen in other studies, so we kind of expected to see these things. But we have a lot more, this is all preliminary, and we have a lot more data investigation to do. I'm really interested to see why the microplastics might have been affected differently by environmental parameters based on their the microplastic category. We've learned a lot also with this project, and I'm excited to share with you, any of you, if you're interested in doing something similar, the things that we've learned. I'd also take any suggestions for future data analysis on this project. Just want to share with you some excellent references and acknowledge Galveston Bay Estuary Program for our funding for this project, and remind you to go check out Turn's poster in the poster session. I think Morgan has some interesting facts about their citizen science stuff that they've been doing.
Excellent. We do have time for a couple of questions. Yes. Okay, I'll repeat the question so people online can hear, but it looks like you were going through and looking at the microplastics manually, and how long did that take? And then maybe you can repeat the last part.
Right. It was incredibly time consuming. Like I said, we learned a lot. When we first started counting our filters, because we were trying to be so meticulous about it, it would take us up to 2 hours going through one small filter. We follow the grids in a zigzag pattern to try so that we make sure we're not double counting anything. We try to scan at about 4 times power. So we're close enough up that we aren't missing any pieces that are so small, but also far enough away to understand the direction we're going with the filter. So it was incredibly time consuming. We did build upon our skills as we were going through our filters, and our average time by the time we completed was around under an hour. So it is incredibly time consuming, but I think that they're there were efficiencies that we learned in doing this. Yes.
So the question is, are you, maybe the reason you're seeing microplastics more in one time versus another time is because there's more people out?
Yeah, I think that's an excellent point and definitely worth investigating. To look into the number of people in the area.
Okay, thank you very much.
Thank you.
Okay, our next presenter is William Bailey, and he'll be talking about fate of microplastics in Texas bays.
Okay, good morning, everyone. My name is Will Bailey, and today I'm going to talk to you about the results from my second year of my PhD research. So we're taking a sedimentological framework to looking at the microplastic problem in Matagorda Bay, Texas, where we're mapping the distribution and concentration of microplastics to better understand bay dynamics. And the key questions we're looking at is where microplastics are depositing and concentrating and why that may be. And then the key controlling factors, such as do they correlate with grain size or areas such as net aggradation or depth or erosion. And then secondly, we'll get into a hypothesis that is quite recent, whether microplastics may not be concentrating in a specific area due to the prevailing winds or tidal currents. So our project entails 3 years of sampling campaigns, and so far we've collected nearly 150 sediment samples and water data. We have around 90 or so grab samples looking at the upper 10 to 20 centimeters of the bay bottom, and some push cores ranging from 2 to 5 feet, and then some water column data, which is at MSI currently, and then we're also scanning for bathymetry. And then I also have some new results. We're looking at some shorelines around, looking around the Matagorda Bay. So as Emily and Zulamar said, we are tediously separating the microplastics from the water and the sediments. This involves a density separation procedure with a heavy liquid. So basically everything that's less dense than the liquid will float to the top, where then we can vacuum filter it out, put it under a microscope and manually point count them. And then we send it to an FTIR analysis at MSI. As Zulamar said, this is quite challenging and open to user bias and trials and tribulations related to organic material. We are working through that as other studies are. This is an example of a way that we are trying to QC these results. We can put it under the FTIR where we've tried to confirm it under visual examination with a microscope, and then we can look at the results in the polymer library to see what it comes out with. And, while we can visually identify a, bright green fragment that looks like a piece of fishing line, we can then put it into the library and see if it actually is. And we're still working on those results. But anyway, we're looking at the concentration of microplastics from 100 grams of sediments, which we can then scale up to relate to other studies looking at a kilogram or a square meter. And then we plot it into our study area. So this is a distribution map of fibers in red and fibers in green, where the pie charts are the proportional size of particles counted per location. This is looking at particularly the grab samples and microplastics per 100 grams of sediment. And what we can see is we have our highest concentration proximal to Port Lavaca, or the highly urbanized and industrialized area. We also have somewhat of a trend along the barrier system. And with our sediment data, this is a 1979 distribution map of grain size. We're going to update this, which will be a really great deliverable for this project. And then on the right, we have some of the examples of the microplastic fibers and fragments that we found, as well as an example of where, when we're close to rivers, we get a significant amount of organic material that we're currently trying to figure out how to get rid of. And when we try and compare the broad numbers of what we're finding, we're maybe finding tens to hundreds per kilogram of sediment. Other studies are finding thousands to hundreds of thousands. So our numbers are a little bit low. We also didn't find any inertals in the sediment. So we're trying to figure out and hypothesize where the plastics could be going. And to test this hypothesis, we're thinking these particles may have a higher residence period in suspension compared to the sediment that's filling the bay, and thus may be controlled by the prevailing winds and currents. And what we have in our study area is a prevailing onshore wind most of the year. And we decided to look downwind where floating particles may be transported. And what we have downwind in the furthest downwind position in the study area north of Aga Bay, we have a series of tidal ponds and creeks where plastics may be sourced from from the cities towards the bay, as well as a unique plastic point source, and be concentrated where we have increased vegetation or restricted water flow. Then we can compare these shoreline data sets with the data from our grab samples in the bay. The second area that we're looking at is the recent Colorado River Delta deposits, which constitutes a pretty unique timeline. The Army Corps of Engineers diverted the Colorado River Delta a series of times into the western part of Matagorda Bay, which aligns with the same time that plastics became globally mass production. So we can go in here, probably push some cores through it and see if we can find the base of where these plastics may be coming into the system and see if they correlate with an area of rapid deposition. So we have some locations where we just went out this past January. We found a local fisherman who's been here for a long time, and he took us to what he calls the plastic beach. So during the winter, a northerner storm typically deposits all of the plastic, he believes, into this one location near the Garcitas Creek. And so we went out here and we did a shoreline transect where we're trying to test if there is such thing as a microplastic gradient from the water's edge towards the more vegetated section where there's less interaction with the water on a daily cycle. And then we also went to an area just across the river where there's a lot of wind-driven wave erosion along these river terraces. Another area that we tried to explore was to see if there was a microplastic gradient along the Matagorda Beach. So looking at stuff that was deposited recently on more like a daily timescale to more like a seasonal timescale, and then stuff that could be more preserved until a significant storm or hurricane washes over these dunes, and to see if to test about if the spatial and temporal storage capacity of these barrier systems and allowing the transfer of plastics between the bay system and the Gulf. And to further go about testing this idea of a spatial and temporal storage capacity of the bay, we're thinking about this variable that we're calling the bay flushiness factor. So this is talking about or trying to describe when sediments are put into the bay and we have a low volume to area ratio, winds can easily resuspend a lot of material and export it to the Gulf. And what we're seeing in the literature is that these bay systems have a very slow sedimentation rate, and this may be related to their location on a storm-dominated coastline. This is a very high resolution daily satellite imagery data set that we're looking at to see if we can calculate volumes of suspended sediment concentration. And this is an event related to a flood, inland flood, which flushed a significant amount of sediment and probably plastic from the Colorado River watershed into the Matagorda Bay system. And we can try and pick out some vortices and vectors that may help us describe the bay sediment transport dynamic. And then conversely, I missed a point. So this is getting after the idea of a sediment budget, of a microplastic budget. Some studies have suggested just in the Colorado River Delta that plastics sourced from the Texas watershed could be in the billions to trillions of particles. But our analysis from the sediment can't really justify those numbers as of yet. So we're thinking about how much is actually remaining in the bay versus exported out of the bay. Similar, looking at that PlanetScope data set, we can see on a daily cycle a significant amount of sediment that is exported out of the system, which would probably relate to plastics exiting the system if they're in suspension. And then just doing an off-the-cuff calculation using the Neural Patrol data as a proxy, and we're seeing, almost double the amount of plastic along the coastlines transported probably by longshore drift away from the system as compared to those that are remaining on the bay shorelines. So we're trying to come up with a model to describe this flushiness factor. We have some observations from the different barrier systems, such as St. Joe's and Matagorda Peninsula, where after storms, they have these rack lines that are that have a lot of plastic debris. We actually can see a lot of nurdles in there, which some people in the room have collected, and we're trying to figure out why they would be concentrating here. So our model is talking about how we could have plastics deposited in the bay sediment as well as in the Gulf, and then during a enhanced wind activity such as a storm or a hurricane, we have a breach of the barrier transporting plastic from the Gulf into the bay, resuspending a lot of sediments that can then be transported offshore when the winds and floodwaters recede, and plastic is then trapped behind the preserved dune topography and ultimately reaching the Gulf and potentially cleaning the bay of the microplastics that were temporally deposited in there. And with that, I'd like to thank you for your time and open it up to any questions and emphasize that we don't have the entire story here. And if there are any opportunities for future collaborators, I'd love to hear from you. Thank you.
Excellent. Great. Okay. Any questions? We have time for a couple of questions. Here. So
Yeah,
let me repeat it. So on one of your maps there, you had an arrow pointing to Nurdle source. And so what was that?
That'd be Formosa.
Okay, well, thank you. Okay, next up, we have AI Hernandez Soriano talking about microplastics and solid waste study on marine and coastal ecosystems in Mexico.
Hello everyone. I'm Anna from Mexico City, and I'll present to you microplastics and solid waste study on marine and coastal ecosystems in Mexico. So we all know Mexican beaches because they attract many tourists from all of the world and from inside Mexico too, because they are very beautiful. And they have helped economic growth in the recent years, but that has led to an increase in population and also to waste mismanagement. And that added up has resulted in solid waste pollution, and that doesn't come alone. There's not only a solid waste problem, but also a microplastics problem in the beaches. So Mexico has around 11,000 kilometers of shoreline, which include 17 of the 32 states. And Mexico's waters are divided into 5 regions, 5 principal regions, which are the Pacific Northwestern, the Gulf of California, the Tropical Pacific, the Gulf of Mexico, and the Caribbean Sea. Each of these regions face a lot of problems, but one problem that all of them face is, of course, plastic pollution. And that's why in 2017, the group Microplásticos en Ambientes Marinos, or microplastics on marine environments, was settled by the Universidad Autónoma Metropolitana, based on Mexico City, and now works alongside the Universidad Autónoma de Baja California. And our main goal is to characterize and quantify solid waste and microplastics on marine ecosystems and on all of Mexico too. So for that purpose, cheap and reproducible methodologies have been developed for solid waste on the selected beaches. 100 meters were measured, and those were divided into 20 sections of 5 meters each one. And then 5 random sections were selected, and all the waste on those 5 sections were collected and then classified in those groups. And for microplastics, on the selected beaches, the same 100 meters were measured, and the high tide line was identified. And then 10 random points were selected, and samples were taken in those 10 random points. The samples were taken with a cylinder like that, which is 5 centimeters on depth and 19 centimeters on diameter. And the samples taken for the results I'm going to show you were taken to the lab and dried there for 24 hours. And then the microplastics were extracted, microplastics from sizes from 1 to 5 millimeters. And they were extracted by flotation first with a calcium chloride solution. And then the organic matter was removed with an acidic solution and with an oxidant solution too. And then they were classified by chemical composition with infrared spectroscopy for the microplastics from 2 to 5 millimeters. And they were also classified by form and color. First, 70 beaches have been sampled for solid waste, and around 100 beaches have been sampled for microplastics. But I'm just going to show you results for solid waste for 13 beaches. In these 13 beaches, 6,847 pieces were collected, from which 3,340 were fragments. And by region, plastics were, as expected, the most common type of material. We classified foam as separate group because of their abundance, and also cigarette butts because they were very abundant too in all of the regions. And if we were to add up those groups, well, plastic waste would be much greater. And as I told you, cigarette butts were very abundant too, and they are considered as plastics by the United Nations Environment Program. So plastics are very, very common on Mexico beaches, like all around the world too. And these are the top 3 waste found by region. In almost all 5 regions, plastic was the most common material, but in 2 regions, we found also metal caps and glass bottles. And the pollution index was calculated for 11 beaches. The mean value for these beaches was 7.2 pieces per square meter. And the pollution index indicated that on average, these beaches were moderately polluted. And another interesting finding in beaches on the south of Mexico, the state of Quintana Roo, like Mahahual or Holbox, is that international waste has been found. These are examples of bottles from Jamaica, Haiti, South Korea, even Russia or China. And this can be attributed to, of course, tourism, but also marine currents. And for microplastics, these results are from 33 beaches. The values range from 31.7 to 545.8 microplastics per square meter. And the concentrations for almost all of the beaches went from 0 to 2.9 microplastics per kilogram of sediment. And for all of the microplastics collected, rigid and semi-rigid fragments were the most common, but also foam was very common. And white was the most common color, but also green, blue, and yellow were very common. And these are some examples of the microplastics that were collected by form. Fibers, pellets, ammunitions for toys were also classified as a separate group because they were very abundant. And rigid fragments, foam, and film fragments. And by region, as expected, polyethylene was the most abundant polymer or type of plastic, but also polypropylene was very abundant in all 5 regions. And as I have told you, fragments were the most common, with more than 50% in all of the regions. And further research is being done by the group. More than just beaches, we are sampling to mangroves and rivers and lagoons, and we are researching to microplastics on fish, oysters, and shrimps, for example. And where in conclusion, all the solid waste that was found on the beaches was generated from recreational activities, which reflects, as we talked earlier, about the waste mismanagement and the lack of consciousness from people or tourists in this case. And for microplastics, the standardized methodology was really helpful to compare pollution on the beaches. And the results found, well, the concentrations found were very similar to other studies around the world. And, well, of course, waste management policies must be implemented in the beaches, with special attention to the recreational activities. And I am very pleased to inform you that this information I've just presented has contributed to strategy development for marine pollution to prevent and mitigate the pollution on the beaches. And that would be all for me. there is my email. If you have any question, I will be happy to answer. And that's the Facebook page of the group. And thank you.
Great. Thank you. Are there any questions? Yes, right here. So the question was, are there areas that there have been successful practices put in place for capturing trash?
Yes, there are some beaches that they have prohibited, for example, forks and spoons, like these one-use plastics items, and that has led to a reduction in solid waste there. Yeah.
See another question back here? So the question was, in the southern Baja California, looked like that you had the highest concentrations of trash. Do you have ideas of why that is?
Yeah, I didn't mention that, but yeah, you're right. That's the place where the highest concentrations were, and that's because when the samples were taken, a hurricane had just gone through, so that led to a significant increase in microplastics and solid waste. Yeah.
Okay, thank you very much.
Oh, thank you.
Okay, so our last presenter for this session before we go to break, oh, here we go, okay, is Annabella Willems, and she's going to be talking about tracking trash. It's the laser.
Hi, my name is Annabella Willems. I'm an 8th grade science magnet student at Seabrook Intermediate, and this is my science fair project, Tracking Trash. Have you ever wondered what happens to the water bottles that fall out of your car and into creeks? Well, hundreds of miles of bayous and tributaries that flow into Galveston Bay are impacted by non-point source pollution. This project was chosen to demonstrate the path of marine debris dropped in local bayous. This idea came from personal observations of marine debris along Bayou and Galveston Bay shorelines. My research question was, what is the effect of marine debris drop location on the resulting route and speed of marine debris? These are the materials I used. I put 10 land, air, sea trackers into 10 Powerade bottles. So my different dropping locations included Cedar Bayou, Buffalo Bayou, Horsepin Bayou, Clear Creek, and Braised Bayou. Bottles were deployed at 5 different identified locations around Houston, and using the Land, Air, Sea app, they were tracked each twice per day for 10 days. There were 2 trackers in each location. Here are the different dropping locations. The red is Cedar Bayou, orange is Clear Creek, teal is Horsepin Bayou, yellow is Braised Bayou, and blue is Buffalo Bayou. The next few slides will show the routes taken by both bottles down the bayous. Note that the Land, Air, Sea app didn't record each individual movement, so the maps only show the general distance from start to finish. First is Buffalo Bayou. Tracker number 2 was actually picked up by the Buffalo Bayou Partnership cleanup boat. We saw via GPS that it sat in the dumpster for a while and then moved to the Atascocita landfill. So, yay. Next is Braised Bayou. Tracker number 2 got stuck and bounced around within the marsh closer to the dropping location and further downstream, actually into Buffalo Bayou. It got stuck between a barge and a dock and bounced around for the remainder of the 10 days. Clear Creek, Tracker 1 went further downstream, while Tracker 2 stayed further upstream while bouncing around within the marsh. Horsepin Bayou, both of the trackers lost connection within the 3 days. The tracker in the bottle had to be above water surface in order to record the GPS data. So the weight of the tracker contributed to the weight of the bottle and caused it to sink. Cedar Bayou, tracker number 2 bounced around within the marsh a lot and didn't lose connection throughout the 10 days, while tracker number 1 did lose connection around day 5. This graph shows the average bayou distance. Braised Bayou had the longest distance and Horsepin had the shortest distance due to loss of GPS signal. Shows the average bayou speed. Horsepin went the slowest due to loss of signal, while Buffalo Bayou went the fastest. This shows the tracker's daily speed and the rain events. On track, one of the tracker and Braised Bayou moved the fastest during the second rain event, while the others ended up slowing down. When it rained, some of the trackers went upstream and then back downstream and moved faster and further through the bayou, while some of the trackers lost connection. Braised Bayou went the furthest distance and Buffalo Bayou went the fastest. However, tracker number 2 did get picked up by Buffalo Bayou Partnership cleanup boat. Cedar and Clear Creek, we saw the trackers bounce around in the high vegetation or marsh, and many of the trackers lost their signal throughout the 10 days. This experiment shows how wetlands and marshes are so important to filter out pollution such as marine debris. This experiment, the areas that are more developed, Braised Bayou and Buffalo Bayou, have no marshes or vegetation to help catch the bottles, causing the bottles to go further, while the areas that are less developed, Cedar, Horsepin, and Clear Creek bayous, have more marshes, causing the bottles to get caught in the vegetation. This experiment was only able to run for about 10 days. It would be interesting to see what would happen if it could run for longer, maybe a few months. I was expecting the bottles to go to travel to the bay within the 10-day time frame, and that did not happen. Kudos to the Buffalo Bayou Partnership cleanup boat. It works. We do need more of them. Unfortunately, one of the bottles did not get picked up by their boat, so there we go. We could use GPS trackers to identify where trash is accumulating, to have targeted cleanup boats, and on the water cleanups to get the trash that are caught in the smaller bayous and marshes. Thank you to Clear Creek Education Foundation for the grant to purchase the trackers. As a part of the grant, I said I would host a trash cleanup to mitigate the trackers I wasn't able to collect at the end of the project, which I did in February with my friends and my sisters. Any questions?
Excellent presentation. Thank you. Any questions? Right here. Okay, so first question was, did you win the science fair? And then second question was, how much do the trackers cost?
Unfortunately, I didn't even get to district science fair. I only was in my school's science fair, and the trackers costed about $300 for the 10.
All right, any other questions? Oh, up here, okay. Okay, so the question is, what is the expected life of the trackers?
So for the subscription, you could choose how frequently they updated. We chose about every 2 hours because the more it updates, the less battery life they have. So with the 12, they lasted about 3 months for a tracker.
Okay, any other questions? Okay, another one over here.
Thank you.
Okay, well, with that, we're gonna go ahead and go into a break. I do have a couple announcements. So if you have a poster and you have not put your poster up yet, put that up now during this break. If you are one of the 2 people that have not submitted your presentation yet to Matt, do that. And let's meet back here at 10:30 to get started on the second session.
Good morning, everybody. We're going to go ahead and get started with our next session here. My name is Matthew Abernathy. I'm the Education and Outreach Coordinator with the Galveston Bay Estuary Program. And once again, we're really excited to have everybody here. So for our first presentation after the break, we have Miss Erin Kinney, who will be doing a presentation, Litter Across Texas, the analysis of the Texas Litter Database. Yes.
Good morning. I'm sorry, I'm going to have to get started even as people are trickling in. My name is Erin Kinney. I'm a research scientist with HARC, the Houston Advanced Research Center. We're a nonprofit research organization. We do air, water, and clean energy research. And today I'm going to be talking about some of the litter data that we've been working with and our efforts with Keep Texas Beautiful and Black Hat GIS to collect all of the litter data, or at least provide a landing place for all of the litter data across the state of Texas. And this project really started about 6 years ago with a group of us here in the Houston-Galveston region getting together to talk about trash. And we called it the Trash Summit. And as Lisa Marshall mentioned this morning, we are not having a trash summit for the first time in 5 years this year because, well, most of us are here. So welcome to the unofficial Trash Summit 6. And that group started calling ourselves Partners in Litter Prevention. And we developed a Galveston Bay aquatic debris action plan. And if you want to see a Galveston Bay watershed aquatic debris action plan, and if you want to see that plan, you can go to HARC's table downstairs. And essentially, we distilled all of the issues that we were seeing around litter and trash on land, in water, to 3 main goals: remove, reduce through prevention, and research. And under the research goal, we have recognized a call for access to the data that is available statewide. We knew a lot of our partners were collecting data. The problem is you had to know who to ask. And it was really challenging to pull all that together to do any sort of research regionally, much less statewide. And so we wanted this database to be flexible, open access, and support all types of metadata. And that's how the Texas Litter Database was born. And this really answered a need for a statewide litter cleanup database. We developed it with Keep Texas Beautiful, Black Hat GIS, and also support from testers, many of whom are here in this room and across the state, who told us how their volunteers collect data, what they do with those data, what their metadata look like, what their training look like, so that we could build something that was robust enough to accept almost anything. So we can accommodate large multi-site cleanup events down to just a person who wants to report what they collected while they were out plogging. And it's also a site for our Take 2 for Texas rapid assessment, which is a 2-minute bottle count, which we're hoping one day to be able to correlate with general litter abundance. At the end of all of this, we have easy to download data. The entire database is downloadable. And then we also provide some mapping and graphing capabilities for folks who don't have access to that. So we're collecting data and metadata from cleanups, regular removal, reported trash, any type of amount, be it volume, weight, recycled. We're very interested in developing conversion factors. The location information can be georeferenced with the device that you're holding, or you can enter it later or enter your cross street or waterway. Obviously date, time, and place, but also things like number of volunteers and the ages of those volunteers, miles or area covered. We accept it all. And then we ask about QA process. How do folks check their data? How do they train volunteers? And we use our data partners for a lot of that information. So this is the website, txlitter.org. And if you are not already signed in and you do so today, Amanda Hackney at Black Hat GIS has designed these awesome stickers. She's got about 5 or 6 different designs, and we will give you one if you show us that you are now logged in. And so our data partners here, you can link directly to their existing cleanups, or you can create a new event and enter data on your own. We have developed the STOP methodology, which is very similar to NOAA's, with some additional information that is pertinent to Texas beaches like shotgun shells. If you want to take a look at the overall data in the Texas Litter Database, you don't have to graph a thing. We have done that for you. These are the major categories, and then we've selected some of the most abundant trash types. If you click on one of these categories, it will disappear. So you can just look at the ones you're interested in, copy and paste, and it's ready to go in your presentation. This is the Take 2 bottle counts. You can change your dates down here, and then these are some fast stats about everything that's in the database. And if you want to know where these cleanups are happening, that's what this map is for. So when you enter data into the Texas Litter Database, in about 2 hours, it should be in that database ready for download, and it will show up on this map. And if you zoom into these clusters, you can get down to the actual cleanup location, click on it, and it will give you all the information that's also in the database. And you can sort this by 9 different representative types of data, or you can just do the whole thing. And here's the download. We just ask that you agree that to stipulate that these aren't your data and that they're open access, and then they're yours to manipulate as you will. And so my goal before this presentation was to talk about all the data statewide. Unfortunately, what I found is that when I looked at some of the other regions, I only have 9 audited litter reports in the county surrounding Austin and 4 in the county surrounding Dallas. So we had quite a bit more, over 300 in the Houston-Galveston region. So these are the data I'm going to be talking about. But this is just a first glance. I mean, I really just wanted to show what some of the folks who are going out and leading volunteers are going to want to know, which is, what am I going to see the most of? What should I be prepared for? And so what we found when I separated it out by water sites versus non-water sites, at the water sites, bottle caps, plastic bottle caps, were by far one of the most abundant types of litter found at most of the sites. At the non-water sites, we saw actually bottle caps weren't very abundant. But when we looked at the bottles themselves here in blue, they're much more similar across those different sites. So already we're seeing a difference in the type of trash that is going to be most visible to folks who are out there. This is plastic film, film food or drink wrappers, and that includes fragments. And so those were some of the most common that we've seen in the lower Galveston Bay watershed. When I looked at those Dallas audits, again, there were only 4. Overwhelmingly, number 1 was straws. That really didn't even factor in the Galveston Bay sites overall. Followed by plastic bottles. Again, we're seeing a theme here. Cigarette butts were much more prevalent. Food containers, face masks were huge at one site, and paper and cardboard, probably because they're not being washed constantly on those coastal sites. So if I was to be going up there, the beauty of the Texas Litter Database is I can go into the database, find out where these straws were collected, and most likely find out who reported them and call them and say, hey, where were you? Was there a food truck park right nearby? Is there something else I should know about this site? The goal of all of this data for a lot of us researchers is to put us out of business. We want to start working towards prevention, but if we don't know what's out there, how do we develop those strategies? So those 9 counties surrounding Austin, again, plastic bottles top the list of some of the most abundant, followed by bottle caps, cigarette butts again. But then down here, there were over 700 aluminum cans in one site. That is not the kind of thing that we see in our Galveston Bay sites. So again, now I have the opportunity that I found that data point to call the person who collected it and find out more about that location. And again, we try and denote them by type of collection as well. So was it a park, waterway, other, downtown streets, some combination thereof? So for that regional data comparison, not surprisingly, location type is a factor in the relative litter type abundance. So where you're standing and how the water or wind got it there is going to factor in. And really that's going to then affect what you're going to do if you're going to work on prevention and removal. Unfortunately, not enough litter data for a statewide comparison, but the preliminary results show that location could impact things like cleanup gear that are needed, the weight to ratio of the litter. If we're going to be looking at conversion factors for folks who don't want to audit their litter, we need to know what's most abundant there. And if we're going to be seeing things that are more or less dense, because that's going to impact how we estimate how much has been collected. And also, this could really change the litter exclusion device designs in these different locations. And if you're going to do outreach similarly, that could really impact it. But we really need more audit data. So if anyone wants to be trained on STOP, which is the methodology that Black Hat GIS has developed in ground truth for us, Amanda Hackney offers trainings. You can go to her website, blackhatgis.com/stop. She's actually presenting today as well at 2:15 on some of her research with these data. And then we're also asking for folks, please ask your volunteers to weigh their bags, get them an inexpensive fish scale, get them some way so that we can get more metrics surrounding the types of litter collections that our volunteers want to do, so that we can get it into a format that we as experts in this field can use. So I'm hoping that with funding in the future, we'll be able to continue to improve the Texas Litter Database. My dream is to have the ability to convert data from other formats. There are a lot of folks here who are already reporting to CleanSwell, to NOAA, to other apps. And if we have some funding to do that, we can create a methodology to get that into the Texas Litter Database in a way that is more quality assured, but also makes a much more robust data set. I'd really like to see more support for audited litter collection across the state. A lot of big cities don't do this because they don't think people want to, but if they had connections to, say, some of the amazing Texas master naturalists that we have seen do phenomenal litter audits, there might really be a way to get a hold of what's happening in some of these more urban areas. We also want support for metadata collection. We want information on what size bag your volunteers are reporting, how much they weigh, is the bag all the way full, and the kind of types that they're using, so that we have a better idea of what people are doing on the ground. So thank you. And I hope, if you haven't already, that you will register in the Texas Litter Database. And if you have any questions, please feel free to email me at HARC.
Thank you very much, Aaron. And we do have some time for questions. Is anybody questions from the audience? Yes, in the back.
She asked for the 700 aluminum cans that were found in that one Austin area site. I have not had a time to contact them yet, but I might actually have one of my interns do that this summer.
Any other questions?
Yes. So you're asking if we have some metadata and data guidelines to help folks kind of contribute to this database? We do. So the STOP methodology that Black Hat GIS developed with HARC and our other partners is extremely detailed. And so we've got hundreds of different types of litter if you want to put all that in, but you don't have to. You could also do a sub audit of your overall collection and just report kind of what percentage of what you've collected is part of that. So if you go to txlitter.org, we have a lot of information on the types, the methodologies that we suggest, but also if you want to keep it simple, you can keep it simple.
I think we have time for one more question if anybody has one.
Yes, in the back. I think you're asking if some folks aren't willing to do this kind of detailed audit, what are some strategies to kind of work around that? One of the options is, if you can reach out to some groups who are more inclined and understand the value of that data, partner them up. So if you have, let's say, a community group who's willing to collect litter, maybe then connect with the local master naturalist chapter who could audit a subsection of that. So we have a better idea of the general makeup of that cleanup, even if they don't go through every single bag. That would be one of my suggestions. Yes. Right. So when I'm saying audit, is what I mean is that if you have a cleanup effort and you have a whole bunch of folks who go out and collect and they're putting it in bags, do things like weigh their bags before they get tossed onto the truck, record what size bag, or give everyone the same size bag so that you know kind of what you're working from. And then the full audit would be either there at the site or later on. Take all of those bags, some of those bags, whatever subsection you desire, dump it out on a tarp and actually go through and identify. We have 27 plastic bottles, 57 cigarette butts, 350 fragments, and and 75 straws. And that kind of detailed information is extremely valuable for anyone who's trying to, for instance, go to Austin and lobby lawmakers to pass new legislation.
All right, I think that'll do it for questions for this. Well, thank you again, Aaron. And up next, we have Charlotte Craft, who will be doing designing for circular economies, creating impact from local plastic waste using off-the-grid containerized 3D printers and practice-based learning. Yeah, center's the laser.
Centers the laser and then the
Forward
buttons.
and backward should be.
Okay.
All right, there you go.
Good morning. Imagine, if you will, that the plastic drinking cup that you were using this morning could be transformed into the chair you're sitting on. Or the trash that's polluting our cities and our rivers could become tools for your factories. My name is Charlotte Craft. I am the ambassador for Re3D, and I have the honor of representing our organization as part of a project called Designing for Circular Economies. Our project is an international collaboration focused on transforming plastic waste through community-led fabrication. We are working on creating a micro factory that can be used by low-income homeowners at Austin Habitat for Humanity Restores to design sustainable home goods recycled from materials that are donated to the home stores themselves and manufactured on site at those places. Our partners in this effort include the Restore themselves, the University of Texas at Austin, and 2 Australian universities, Western Sydney University and the University of Wollongong. My company, Re3D, is actually just down the street from here. Our factory is in the Clear Lake area, and we are a social enterprise that is focused on decimating the cost and scale barriers to 3D printing by creating jobs and enabling people to solve local problems. And what we do is we make large format industrial 3D printers. The first one we made works with filament, plastic filament that's spooled. And then we adapted the 3D printers to take in granules, pellets, flake, plastic waste. So on the left side of your screen is the filament baseline. And then on the right side, you'll see printers with hoppers on the top where plastic can be poured directly into the printer and then extruded to produce something new. So this project spun out of an effort that started in 2019. We were part of the reverse pitch competition, which was sponsored by the city of Austin and Austin Resource Recovery. The company HID Global has over 5,000 pounds of waste polycarbonate that they landfill every month. And they pitched companies to come up with a solution for something to do with that waste. We reverse pitched them and were lucky enough to get supported for that effort to 3D print with their waste polycarbonate. And through that effort, we met William Stockton, the Vice President of Operations at Austin Habitat for Humanity, who provided us a space within the restore to granulate waste so that we could get it down to a form factor of about 1 to 5 millimeter diameter pieces that could be processed in our printers. And from that, we adapted our printers to be able to use that material. And in 2021, we started 3D printing with waste polycarbonate and other plastic waste in the form factors of planters, decorations, chairs, stools, that kind of stuff, home goods. This effort didn't stop there. We wanted to figure out a way to bring the manufacturing process closer to the areas where waste was located. So we, during the pandemic, kind of conceived of this idea of a micro factory with all of the tools you might need to take waste from a trash form, reprocess it into a small particle, and then put it into a 3D printer to be able to be used to manufacture all sorts of new things. And with this, we asked a bunch of friends of ours who were doing research in all sorts of different areas, whether they would go with us into a new project from the National Science Foundation, which is called the National Science Foundation Convergence Accelerator. This is an effort from the National Science Foundation side to take research from disparate areas, converge them together towards an effort for societal impact. And we were lucky enough to be granted a phase 1 award for this project. So we are currently in the planning phase. And I'm going to talk through a little bit of what we've done within that effort over the last few months. The first thing we did is we audited the plastic waste that was at Austin Habitat for Humanity restores, waste that they got in but couldn't necessarily sell in the stores. We discovered there was a lot of polystyrene DVD cases, polypropylene and LDPE Tupperware awaiting disposal. And the biggest thing they get donated that they can't really resell very well and takes up a lot of space in their storage areas are storage totes. So usually those are made from polyethylene or polypropylene. We broke down this project into basically 4 main quadrants. On the design side, that's led by the University of Texas at Austin under Dr. Carolyn Seepersad. They are developing an algorithmic topology design to enable them to make a user interface design tool where you don't have to use complicated CAD software to design a new 3D model. You can use a series of sliders, so it's effective for people who are not trained how to use CAD, and they can make a custom design from a few pushes of a button. And they have generated a fair number of design options, and then they translate those into 3D models that are automatically prepared to be 3D printed. On the training and installation side, that's led by us at Re3D. We have manufactured these machines for a few years now, and we've actually made GigaLabs for other areas. We have a GigaLab going online in Puerto Rico right now to do a similar project with local waste on the islands. And we also have projects for GigaLabs for smaller communities and particularly Army sites, and the U.S. Air Force Academy is building GigaLabs for them as well. And so we're taking the training materials that we've adapted for those GigaLabs, translating it for use for training up laborers, upskilling them to new technology skills like 3D printing, processing waste, and 3D modeling and operating machines. On the side of making sure that we're doing our sustainability due diligence, we've implemented life cycle analysis processes for both the manufacturing of new items from waste plastics and also from the microfactory itself. The University of Wollongong is leading the life cycle analysis of our GigaLab. They have a lot of experience creating net zero buildings that the energy is as sustainable as possible. And so they're analyzing what we have built and are going to make recommendations to change that. The University of Texas is doing life cycle analysis on manufacturing plastic goods through traditional means or 3D printing means, and giving us data on whether that's going to be the more sustainable option and how to make that happen. On the third side, the Restore itself is doing integration. So they are marketing this project to within their community, identifying other partners within the community who can help support the mission, and build up more potential trash providers from the Austin communities who could donate maybe manufacturing waste that could then be transformed into goods of value that are sold at the Restore to support the Habitat for Humanity missions and are designed by low-income homeowners themselves to support their needs. That's where we are so far. I wanted to invite any of you who are still in town tomorrow to come visit Re3D. We're just down the street from the University of Houston Clear Lake, and our factory is there. You can see our machines in work. You can see how we make these crazy things out of recycled plastic waste. And if you have any questions or would like to support this project with your advice and your vast amounts of knowledge, please reach out to me. I'm available at charlotte@re3d.org. Thanks.
Thank you very much, Charlotte. And we do have some time for questions. Do we have any questions? All right.
I barely heard that. Did you say, can I talk about the technical lift that 3D printers use to recycle pellets? Is that what you said? They, yeah.
Real
That's
quick,
it.
just so the question was, how did they adapt the 3D printers to accept plastic pellets or fragments as opposed to the spools?
Yeah, so we adapted a technology that's actually used in traditional manufacturing in injection molding. Most of the plastic items that we use are made with this method. The pellets or the flake or the granules go through an extrusion screw. They're gravity fed down to a feed system that has 3 different heat zones that, as the extrusion screw kind of conveys those materials through those heat zones, the plastic is melted, condensed, and squished together. So by the time it gets to the bottom of the extruder where the extrusion nozzle is, it's one continuous line of semi-melted plastic that we can then lay down in layer by layer by layer form factor in order to take a 3D model and reproduce it in real life. Does that answer your questions? Yeah.
In the back?
Say recycled filament?
Yes, so her university already has a 3D printer and she was wondering where she could get recycled filament.
Yeah, recycled filament is actually available through most filament providers. We partner with a US-based filament manufacturer called GreenGate, and they sell filaments on all sorts of different form factors already recycled. We actually work with them to get their material before they translate it into filament, because plastic, that every time you process a plastic into a new form factor, the chemical bonds degrade in that plastic. And we're trying to reduce the number of times that a chemical bond has to be degraded in order to turn it into something else, which increases the recyclability of that particular material. So we actually work with them on the pre-stage, before the filament stage, and get them as pellets. And then in-house at Re3D, we do our own internal granulating recycling of our own filaments and materials and reusing them within the Gigabyte X 3D printers.
Yes, sir, in the center.
Did you catch that?
I think he was talking about asking about how do they screen out additives and things like that within the material that you produce.
Yeah. Yeah, the question is about how we keep the materials sorted and identify them and that sort of stuff. We absolutely, that's absolutely a big challenge. We have to make sure that we, as much as possible, use single stream plastics within our extrusion. We can switch out between different types of plastics, but we can't necessarily blend them all together, and we can't just take a load of trash and dump it into a granulator together. It has to be sorted. Generally, there's some pre-sorting, identifying the types of plastic, usually by those recycle numbers. They're super useful. We use those, and an understanding of where the material came from to identify that particular thing. We rely on, especially as it comes to manufacturing waste, the manufacturer actually informing us of what type of material it is. And if it's a material that's particularly toxic when processed through extrusion, like PVC, for example, we have a clean room and filtration in order to process that kind of material. But we generally try to steer clear of materials that would, be toxic for any sort of use.
All right. I think we're going to stop questions there, and we want to thank you again, Charlotte, for your presentation.
Thank you.
All right, our next presenter will be Olunye Fadare, and his presentation is on plastics, polycyclic aromatic hydrocarbons, and mercury interactions within the Matagorda Bay system. Does this pose a risk to fish health?
Hi, everyone. Yeah. Good morning. My name is Olunye Fadare. I'm a postdoc researcher at the Department of Physical and Environmental Sciences, Texas A&M Corpus Christi. And I'll be discussing this morning about an ongoing project in our lab that talks about the plastic, the PHAs, mercury interaction within the Matagorda Bay, and the effects on the fish species within this bay. Outline as presented. We know that in the Matagorda Bay system, there are a lot of industrial activities that are going on, and these activities continue to increase on a daily basis, and which is affecting the economy of Texas coastal area. We know that this coastal area has an economy that employs a lot of people and also generates a lot of money for Texas state. And a typical example of this is the Matagorda Bay system, in which the industrial activities is causing a lot of pollution to the marine environment. Here I have the Matagorda Bay system. It's a collection of shallow water bays, about 2 meters deep and covering around 1,100 kilometers square. And within the Matagorda Bay, it is the EPA Superfund site just within this location. This is the Mercury Superfund site by Aqua in the 60s. And within the Matagorda Bay, we also have a Famosa Plastic Company, which has been prosecuted for introducing plastic pellets within the Matagorda Bay system. Our lab is part of the group that is working with the Matagorda Bay Trust Fund to see to the remediation of the long-term industrial pollution within the Matagorda Bay. And our work is defined to look at the interaction of plastics with the plastic that are released by Famosa into the bay, as well as the mercury and other organic contaminants that are within the bay. The objective is to look at how microplastic enhances the bioavailability of organic pollutants, especially PHAs and mercury, and also to examine plastic and mercury in 3 different fish species of economic importance within the bay, and to assess the influence of plastics. We divided the plastic for the purpose of this study to macro and microplastics, and we collected this plastic from the bay system, the shorelines. We characterized them, we quantified the pHs and the mercury concentration on some of the microplastic. We examined the plastics in the 3 fish species, and we are trying to assess the influence of plastics on this bay system. We're working presently in 12 sites within the Matagorda Bay system, and we've done about 6 sampling campaigns from last 2021 up to date. We've collected over 4,800 plastic items. We carry out microplastic sampling in all the 12 locations, while the yellow spot indicates where we have the endemic of microplastic particles. And this is the picture of microplastic on surface of the water in some of the bay location, as we also have here. Also, we have a lot of microplastic that were trapped along the shorelines under the organic matter. And I think this is one of the breakthrough we have so far in our research in this location, and I'm going to talk more about it. Of course, these are pellets that are trapped in nearby vegetations around the bay. This is some of our sampling campaigns. The fish that were collected are red drums, sparkle throat, and southern Florida. We collected the muzzle, the liver, and the stomach, and we also measured different parameters of the fish. Yeah, as I've talked about this, I'm not going to use much time on this, but these are the organic matter that we collected along the shorelines. And this is the greatest progress so far in this research, as we develop a novel method that can actually separate microplastics from the organic matter using just water and ethanol. I'll be willing to discuss more on that at the poster stand. We have our posters there. Then also for the macroplastics, we still have a preliminary data on this. And this is just one of the sites that we collected over 500 plastic items. And Point Comfort has the highest plastic items and different polymer types. These are also at the poster stand. Yes, we extracted the PHAs from the surface of the microplastics. And this is interesting to know. When we discovered over 28,000 microgram per gram of PHAs on the surface of the microplastic that are collected from this bay. And checking the literature, the only thing that we can see very close to this is the sediment within the bay, which is having almost near concentration with the microplastics. The danger in this is this: sediments are not mobile. Microplastics are mobile within the bay system, which means they can move around. More PHAs are within the Matagorda bay system. We have a preliminary data on mercury on plastics, and it's so interesting that for our preliminary data so far, polystyrene has the highest concentration of mercury. And it's so funny that we can have detectable mercury level even in the cigarette boat. These are the three fish species that were quantified for mercury. And we have the red drum having the maximum total, excuse me. Yeah, the red drum is having the highest concentration of 0.1 microgram per gram, but the average, this sparkle throat has about 0.1, 0.6. In all of this, let me summarize it this way, that with the EPA advisory on mercury contamination within the Matagorda Bay, these are the concentrations that were detected from the three fish species. And based on the advisory that the three stand for the best choice of consumption weekly, two stand for a better option, and one start from good, and the zero start from species that must be avoided. In summary of this, we can say that all the three fish species that we quantify are safe to be eaten based on the EPA advisory. And in summary, about 72% are actually a best choice to use, while less than 1% of the fish species within the bay presently should be avoided. This is plastic in stomach of the fish. Unfortunately, this is not from Matagorda Bay. I mean, fortunately, let me say, it's not from Matagorda Bay system. But what do we see in some of the samples that we collected? We see different prey starting from the seaweeds, shrimps, crabs. We also saw metals in the stomach of the fish, and hook and some of the papers, cardboards in the stomach of the fish. This is a hook with a line. We do not consider this as a plastic in the fish because this is due to the domestic or recreational activities within the bay. So it's not willingly consumed by the fish, and we do not consider that as plastic within the fish stomach. In conclusion, Microplastic within the bay is a big reservoir for PHAs, as I've shown in the data presented. Microplastic are majorly from the recreational activities, fishing activities, and all other activities within the bay. The preliminary result for the total concentration of mercury on the plastic is relatively low, and the fish within the bay seems to be more safer, and it's safer now to eat compared to what we have in the past. We still have our data, our processing analysis on in the lab, in our lab. I'd like to acknowledge some of our group members. This is a big project, and we have a lot of people on board, both people that have volunteered to do this work, as well as our undergraduate students. The aspect of this study that talks about the mercury in fish was carried out by Jessica, a master's student. Nigel and myself, the one that worked on the PHAs, and Nigel is also working on the method that we developed to see how it can work for tire particles, as well as the dynamics and the kinetics of this plastic in the bay. I want to thank the Matagorda Bay Integration for funding this study. Thank you very much, and I welcome questions.
Thank you very much. Do we have some questions from the audience? Oh, yes, sir. So the question was whether or not the fish need to consume the plastics that are exposed to PAHs to contract it, or if they can get it without consuming the plastics.
Yeah, based on the data, unfortunately, this study does not cover microplastics. It's more of the plastics within the bay that we are working on, as other groups are working on. But if you look at this, what we've just talked about, we are not looking at the nodules, but we are looking at the smaller particles. We're looking at the smaller particles within the bay, which are less than the nodules, less than 1 mm. Of course, if you want to carry this out in the fish species, it involves more technique and more time in order to detect them within the fish. But I'm really convinced that with the concentration of the microplastic that we have in this bay, definitely the fishes are consuming these PHAs. And we're still working on the quantification of PHAs in the muzzle and the tissues of the fish. And with that, then we can now be able to juxtapose what the concentration is within the fish.
Any other questions? Thank you very much. All right, ladies and gentlemen, at this point, I do want to let you know we have had a couple of last minute changes to the schedule. The 11:30 presentation unexpectedly at the last minute had to withdraw from the symposium. And so what we are going to do is we're going to start the opportunity for lunch a little early. But what I would like to ask is, since lunch is going to be combined with the poster session, if we will let any of our poster presenters that are here go to lunch first, be at the front of the line, so that they have an opportunity to get some food in them, and then they will head to the poster room after that. The posters are going to be available for viewing, and the authors of the posters will be in the garden room, which is where you were able to get snacks, and that's also where your drinks will be available for lunch. So when you go down the stairs, the area where we did registration and networking, if you continue past that to Atrium 2, there are tables set up and all of the box lunches are available there for you, but your drinks will still be served in the garden room, which is where the posters are and where the snacks were this morning. The other thing I would like to say is, just to help us keep on schedule, We are going to be meeting back here for a 1 o'clock start time for our keynote presentation by Ms. Maya Corbett. And so I ask everybody start working their way back in here between 12:50 and 12:55 so that we can go ahead and continue right at 1 o'clock. And with that, everybody go and enjoy lunch, and please make sure to take the time to go and talk with our poster presenters as well. Thank you.
Is this testing? Hopefully they'll get this on by the time. Okay, I think we're ready to get started. Okay, I am honored to be able to introduce our keynote speaker for the day, Maya Corbett. She's the Director of Mission Giving, Garver Black Hilliard Family Foundation, and President of Texans for Clean Water. Just a little bit of background on her. Maya Corbett directs grant funding to mission purposed organizations for the Garver Black Hilliard Family Foundation, focusing on litter prevention through research and policy. She also serves on the boards of directors for the National Stewardship Action Council, Keep America Beautiful, and is president of Texans for Clean Water. Maya previously worked for Booth, Aaron's and Workington, PC, a water law and lobby firm, and as an executive director of the State of Texas Alliance for Recycling. She started her career in waste and water systems at the Lower Colorado River Authority in Austin after graduating from the University of Texas. And by the way, I had to move over here because the Zoom people can't see me over there, sorry. So please welcome Maya Corbett.
Hello, is this, oh, it's on. Hello, everyone. I'm so happy to be here. I've seen a lot of old friends and folks who have been working in this issue and on this event for many years. So I'm really honored to be asked to come and speak with you all today. And I want to make sure that I leave plenty of time for questions. So if you have any questions, then don't worry. I really want to hear them and we want to get to them. So I'm going to jump right in. Again, yes, I'm Maya Corbett and I'm with Texans for Clean Water. And that group used to be Plastic Pollution Texas. And well, we learned that our reality sometimes makes it so we have to adjust our rhetoric. We are now Texans for Clean Water. And we are a group that really focuses on finding data-driven solutions to our collective problems of plastic and waterways that will benefit not just the environment, but the economy. So we meld those two together, and we've worked with those of you, some of you in the audience on those data-driven solutions. And so shout out to Hark and some of the wonderful folks in the room in Black Cat GIS and the great work that they continue to do and have been doing on data. We don't care about what we don't measure. And if we don't measure it, we don't know what to do about it. So again, just want a quick plug there for what the good work is happening. And yes, so quickly also on the reality is plastics are everywhere, on every continent, in every ecosystem, from the beaches to babies, and from the water column to the spinal column. It's a true, it is the definition of ubiquity, but we are ever optimistic that there are solutions out there, and the good work that you all do and the data that you provide are going to get us to those solutions. And there's certainly an increased amount of rhetoric around plastic because of its ubiquity. It is also lucrative. And when those two things converge, we have a little work to do, and a lot of you in the room have worked on let's call it now we call it climate change. We used to call it global warming. So we do recognize that rhetoric matters and the words we use matter and can shape not only the opinions of those that we need to have on our side, but those opinions also shape politics and policies, which are not always on our collective side. So we'll jump right in. Say no to plastic. This is my first, this is the first thing of our rhetoric discussion is this is a trap. For those Star Wars fans, I would do the voice. It's a trap, but it's a trap. You'll see things that say, let's ban all plastic. I just met a friend who's in the Break Free from Plastic Pollution consortium of groups. And yes, we all want to break free from plastic. Those of us who are old enough to remember global warming, when we use that term and people would come and say, you know, I've been to Alaska and it's cold, so there's no global warming. And we learned, and now it's climate change. I just read the last climate report and we're now using Fahrenheit. And I know that might make some of you data scientists just cringe. Why are we using Fahrenheit? Aha. Well, it's because people around here, when you say 1.5 degrees Celsius, it's like, oh, what not so bad. That's what's 1.5 degrees, but when you convert, then you're like, whoa, 2.5, 3 degrees. Wow. Whoa. I know what that feels like when I have a fever. So shout out to some of the folks who also might be in this room who are utilizing terms to meet people where they are, which is unfortunately not necessarily where we want them to be. And so I urge you, when you think about plastic, there's a plethora of plastics, and they are, again, ubiquitous in the clothes we wear, in the medical devices we need to keep us alive, in the cars we drive. And so when we think about say no to plastic, make sure you got that picture in there so people understand, okay, I'm talking about single-use plastics. I'm talking about stuff we don't need. And I only caution this because, for example, I was in a meeting of the Texas Public Policy Foundation, TPPF. They're a political group on the conservative, possibly some would say more of the farther right concerns. And they had a whole session about plastics. Yeah, and they were talking about the war on oil and how plastics, when people say they're going to ban plastics, what a disingenuous argument that is, and how these crazy environmentalists want to take away our cars and our eyeglasses and all the things that plastic are. And so I just, again, it's a trap. Let's not fall down the global warming trap. Oh, you guys want to ban plastics, huh? Well, get in your car and drive over here and tell me that. Put on your little eyeglasses and tell me that. So just to nip it in the bud, we don't have to have all of the plastics, and plastics don't have to do all of the things. So we can, again, adjust our rhetoric to the moment, if not the audience. And the moment is specificity, single-use plastics. We can get rid of those. We really can. Not in all places, not at all times, but we can do something about that. So let's do that. And let's talk about the new words out there, new words. Now, these might not be new to a lot of you, but to the general public, the diaspora out there, there's some new terms getting floated around. And what happens with new terms? Sometimes they get new definitions. And one is extended producer responsibility, EPR. You might have heard that in the political world of plastics. And this is essentially, it's a funding mechanism. And people will say, well, we've had EPR in this state. We have EPR for computers and e-waste. And yes, we do. In fact, there's EPR programs for paint and all sorts of hazardous waste. And it's a concept by which those producers, those who produce something, have some extended responsibility on its end of use, its afterlife. What happens after the consumer utilizes this product? So we've done it for mercury thermostats. We've done it for catalytic converters. We've done it for used oil. We might pay a little fee up front, or the producers might pay a fee that puts together some end of life program, a system for dealing with that waste. Well, that is the new soup du jour for packaging. Well, okay. We don't like all this plastic in the environment just as much as you don't like all this plastics in the environment. So let us handle it. We will, as the producers, we will take responsibility of this. Well, that sounds great. And hopefully it will be. We're not sure yet. There's 3 states that have passed extended producer responsibility, including Colorado, just about our little neighbor to the north. Well, not that little, but they are a little ways up there. And they did a bill that would have the producers of all packaging and printed paper pay for 100% of the solid waste system to deal with those packaging concerns end of life from the consumer. Well, that sounds very interesting, doesn't it? So all these guys, Procter & Gamble, Unilever, Coke, Pepsi, they're all going to pay into a fund, and they're going to pay the cities to pick up the trash, and they're going to pay the recyclers to recycle their product. And gosh, that sounds pretty complicated. We'll see what happens. They've got, I think, 5 years to propagate rules. Maine is also passed EPR, so is Oregon. New York State is looking at EPR. Maryland is on the governor's desk. So this is a growing trend. And again, we're not sure what it is yet. There's a lot of different models for EPR, but what it is, something to be ever mindful about, is it's a funding mechanism. But what does it fund? And that's really where the jury is out. Because as we know that funding is great, we need funding, but we also need to know where those monies are going. What is it going to fund? Is it going to fund collection that gets material from the public to a recycling stream and out of the waterways where we so often find it? Is it going to actually produce funds to get the microplastics, to increase, filtration and really the kind of the totality of what you guys are working on here? Where's that funding going to go? Or is it just going to be another way to capture this material and control the flow of that material? Where does the flow go? Does it go to my factory, your factory? So again, jury's still out on EPR, but it's definitely something to keep an eye on as we progress in the political spectrum of stuff. What do we do with this stuff? Advanced recycling, chemical recycling, molecular recycling, it's all part and parcel of the same thing. Lots of different words getting thrown around, but what this really is instead of taking plastic, which we do now, and we wash it and scrumble it up in a machine that flakes it down to little pieces and extrudes it into nurdles that we all know so much about, and then reconstitutes it into something else. Well, that's a fairly mechanical process. A chemical or advanced or molecular recycling, it takes that hydrocarbon chain either through, it essentially heat or pressure or both, and takes it back to a more crude, quote unquote, air quotes, form. Now there's a lot of ingenuity happening in this realm, and there are those who are looking at this as the next panacea. This is the next silver bullet for plastics. Don't you worry about it. You just throw it all in the bin, and then we'll molecularly make it into another plastic or something else usable, and it'll be fine. Everything's great. And so again, that's one of those things. Jury's still out. We'll see what happens here in Texas. And I'll talk about just a little later. There's a bill that just passed out of committee yesterday that would expand but specify the definition of chemical recycling here in the state. And we are certainly a leader, so we expect that to propagate. But it's very interesting that chemical recycling very well could be an exciting new tool in the toolbox of getting plastics into some usable form of another plastic, as opposed to, utilizing a virgin fossil fuel, but maybe not as opposed to using other materials. And that's where we get into source reduction. Source reduction. Well, that seems to make sense. Pretty straightforward term. I got a source, I want to reduce that source. Well, we'll see what happens with the term source reduction. If any of you has to at some point, we all do, have to use a plastic water bottle, you might notice that some of those water bottles are more like little plastic bags that only have kind of rigidity when they got the water in it, and you like squish it out all over you. Well, that is called source reduction. They didn't necessarily use less plastic from fossil fuels, but we use less plastic in that bottle. So that's great, right? We have reduced our source. So that's an interesting, and sometimes at odds with recycled content, which is another term, a phrase where, whatever that thing is has a certain amount of percentage of another thing that was recycled into it. And we'll see what happens when we get to mass balance and when it pertains to recycled content. So again, you scientists out there, you're like, mass balance, I got this, I know that, I get that. There's a formula for that. There certainly is. And this is the next frontier of recycled content. What does recycled content mean? Does it mean that this whole batch of stuff that I made has a certain percentage of that whole batch had a recycled content in that? Or does it mean that this bottle and this individual bottle has a certain amount recycled content. And that makes a big difference. You know, how am I going to count my recycled content? So a lot of industry folks are putting a lot of effort into mass balance. Let's do this mass balance calculation. And that might be great. That might be great efficient way for industries to utilize more recycled content. Or it could be a way to possibly get around recycled content laws in states that are saying that, you know, each unit should have a certain amount of content in it, because that's the intent of reducing the source of primary virgin fossil fuels. So we'll see how that goes. But again, these are just words. The jury's still out on what these words end up meaning, but it's good to just keep your eye out. And the last one, which I'm sure you all are familiar with, which is ESG investing or ESG goals, environmental, social, governance. This is a burgeoning conspiracy. And in fact, I've sat in rooms where people have said without irony, with straight faces, that this is a conspiracy from China to take our guns. I know it's, you know, I wish it was funny, but it is, there are bills this session to divest Texas funds from companies that have ESG goals. Some of you might have remembered a few sessions ago, it was anti-Israel boycotts, and Texas divested, and we have huge amounts of sums of money that we have billions of dollars in surplus, and Texas divested of sources that boycotted Israel. Well, now Texas is divesting in investments that have ESG goals because it's a conspiracy to get into our finances and find out what we pay for and eventually raise the mortgages for people who own guns. I connect the dots for you so you aren't surprised. Don't be surprised, and just keep that straight face. Yes, okay, I see what you're saying here. Okay, yes. So I'm taking the shock out of your face so you didn't have to do what I did and go, oh, really? Okay, wow, oh, that's what we're doing. That's what we're doing. So just keep that in mind when we talk about rhetoric. We need to, again, adjust to our audience, meet them where they are, wherever, in fact, they may be. Okay, so here are real needs, real needs. California passed Senate Bill 54. I'm not sure if anybody's heard of it. You should Google it. It's a doozy. And this one is probably the most progressive packaging bill, particularly on plastics, at least in this country. And it does all sorts of stuff. And it has real targets and real hammers to those targets with real dates. So by 2032, which is right over the horizon, you won't be able to sell packaging into California, which is 12% of the overall economy, unless you can prove that it's 100% recyclable or compostable, 100%. And you won't be able to put a recycling symbol, that little chasing arrow that you either love or hate. It's a whole nother presentation. You won't be able to put that on any packaging you sell into California unless you can prove that at least 60% of your overall material can be and is recycled domestically. So that isn't we sent it away. When we talk about global treaties, I think some of you I mentioned are really engaged in the global treaties, and there are many. There's a United Nations global treaty. There's a Basel Convention. There's the EU are looking at ways to limit the propagation of plastics throughout the world and throughout different environments in the world. And so companies and industries are looking at serious needs here in the States and globally on how to deal with this true, real problem of plastics. And it isn't just, you know, the bad press and the real regulatory needs, supply chains. You know, that's capitalism. We do that here. We can do that. Well, U.S. industries are really hurting because we use a lot of plastic. We use a lot of plastic and aluminum and all sorts of stuff in our packaging. We use a lot of packaging. And because we don't make a lot of that packaging, we have to import other people's, you know, trash. Right here in Texas, we've got the largest PET recycler in the world in Dallas, and they make plastic bottles from old plastic bottles, bottle to bottle recycling. Best case scenario, we want that. We want bottle to bottle recycling. That's how we're going to close this proverbial loop. Well, those guys are importing empty, well, shredded, but recycled content, stuff from best case scenario, California, who has a deposit system. It gets a lot of material, but they're bringing it in from Taiwan. They're bringing it in from China. We're importing plastic trash because we collect maybe 9% of PET in Texas on a good day. So what we're throwing in the trash or escaping to the waterways, Texas manufacturers are importing from other places. That's crazy. That's crazy. And that is the argument that's working. So there's rhetoric, which is, oh, we want to be good people. We want to do good things. That's great. The reality is it is expensive. And we have real regulatory goals that say you have to do this. So if we have to do it, we've got to find a cheaper, better way to do so. And it also has something to do with national security, which is an argument that plays in Peoria, so to speak, in that, again, we are importing material from places who may not be friendly to us in the past, in the present, and the future. And I know we're here to talk about plastics, but it's not just plastics. Aluminum. Texas throws away more aluminum cans than any other state in the nation. That's crazy. 85% of the aluminum cans we throw in the trash or in a river. That's nuts. So anybody out there, when your recycler says, oh, we couldn't do policy that takes away material from curbside, that's how will we make our money? No recycler is making money in this state if we're throwing away 85% of our aluminum cans. I mean, those are the money makers, people. So where else is the money coming from? It's coming from fees. Is it coming from, material control? Is it coming from throwing away stuff in landfills, which is highly lucrative? It doesn't take that many people to hire to throw stuff in the ground. So there's something else going on. But what is going on is we're importing most of our aluminum from Saudi Arabia and from Russia and from China. And that, again, those are the arguments that are real world problems that are working to move this message along. Also, customers are starting to hear the message. You're all doing good work out there. The drumbeat is getting through. People don't want to buy things in plastic if they don't have to. And those trends are being, scrutinized and noticed by the packaging, cabals of the world. And they're moving out of plastics as much as they're moving the rhetoric towards, hey, let's market against plastic. Our stuff is great now because it's not in plastic. You'll pay more for it because it's in aluminum. And that's, again, it's almost like when you can break into a capitalist argument, you've won because, it's now about the money. It's about how can I make this work for me? And that's again, things are blessings and curses. And so it's a good thing that now these product manufacturers are seeing this as a bottom line issue, as much as now we have to watch out where that goes. Because, as those statistics majors in the room know that statistics can say all sorts of stuff. So who's using it and to what end? Okay, so what's next? What is next? Well, again, Texas is leading the chemical recycling revolution. And I put that in little quotes, not to throw stones at chemical recycling. I really hope that this could be, again, a real tool in our collective toolbox of finding productive outlets for what is now, an environmental degradation and an economic loss. But we'll see. We'll really see where it goes. But it's here. And it's not going away. So there are those of us in the environmental world who, are really afraid of chemical recycling. And I'm not saying you shouldn't be. But again, let's look at our rhetoric and see what fights can we fight? How can we adjust the definitions and the narratives? For example, I just mentioned that House Bill 3060, are the chemical recycling bill. Sierra Club came out neutral. They changed the bill language, and we've got to work with what is happening. And so I urge you all to look critically, but not blindly, dare I say, at chemical recycling as an evil, but as one that needs additional exploration, certainly by the scientific community, but is here. It's here. It's not going anywhere. What is hopefully on the horizon is a national framework for a deposit return system. What's a deposit return system? That's a system that we have in 10 states where when a consumer purchases a beverage container, they might pay a 5 or 10 cent deposit on that container. And then when they return it to a redemption center or otherwise, they get that 5 or 10 cents back. Wow, that sounds like a simple concept. Well, that simple concept of putting a value on a material and incentivizing financially the behavior you're looking for and providing someone with a convenient opportunity to utilize the system, man, it really works. So we've got good data that shows that those 10 states that have these systems in place have significantly higher recycling rates, upwards of 85%. And substantially lower litter rates, 50% less litter on roadways and 30% less litter in waterways, with just putting a price on these materials. That's great. A national framework would boost both our recycling rates and our litter prevention, activities and efforts. I was just in Washington, D.C. last week with the World Wildlife Fund, and they're working with the American Beverage Association. And we walked the halls of DC and we met with the representatives from Mississippi and Iowa and Alaska. So, I mean, this is the most, dare I say, possible, knock on wood, national potential for getting some kind of actual policy that impacts litter and the leakage of plastics in the environment. That isn't to say there aren't a lot of great efforts out there. We talked about the Break Free from Plastic Pollution Act earlier with some friends in the audience. There are some laws that went into the books for recycling funding for municipalities in this last session. So recycling is definitely getting heard, but like DRS systems, deposit return systems, are different and unique in that the public has a say. The people have to be the one to complete that cycle, and they're incentivized to do so. But it also, again, it's proven. We have the data, so I'll leave it at that. But I will also say that state and regional extended producer responsibility, that's coming. It's certainly I hope it doesn't become an if or, but it comes an either or, so to speak, with DRS. There are some packaging concerns that don't want a deposit system, but they would rather have EPR. Why is that? Well, just quickly, EPR, again, it's a funding mechanism, but it mostly funnels material to the curb, to curbside recycling. And curbside recycling is great. We're not anti-curbside recycling. I will say that that's not where litter comes from. People don't go home and open their kitchen windows and chuck stuff out. That's not where we're picking up. We're not picking up shampoo bottles on the street. We're picking up water bottles on the street. So we hope that, oh my gosh, I have 1 minute left. Oh, we hope that EPR doesn't become just pro curbside and curbside only. We need different modalities. We have to meet people where they are. And where they are using the material, we want them to give back for recycling. Okay, so collection is our common cause. Everybody wants collection, and there's no pro litter lobby. So, hey, those are winning arguments, right? You want to recycle it, you got to collect it. And microplastics are the common enemy. There's so much good work happening in this room and in this day on microplastics. Keep it up. I had a conversation with Senator Lindsey Graham from South Carolina. He hates microplastics. So we might differ on the macro, but nobody likes the micro. So good job, team there. Okay, so quick things about the ADA session. These are all bills happening right now. The first bill is the chemical recycling bill that I just mentioned. That has been voted out of committee. Its next step is probably the House floor. So if you're interested in that bill, do take a look at it. The next bill there is the Texas Clean Act. That is a bill that would put together a consortium of people to get to an 85% recycling rate in Texas. That would be huge. Also, we have a deposit return system. on the books this year with Senator Nathan Johnson. It's always exciting to see a DRS bill. And interestingly enough, this DRS bill doesn't have nearly opposition as those in the past. So, we sneak up on them little by little, but we learn something new, make a better bill every time. And then, of course, we've got our zero discharge for pre-production nurdles bills that are out there. So shout out Nurdle Patrol. And then we also have one bill to allow municipalities to prohibit drinking water at municipal golf courses. But that's it. That's it. We've got to get our legislators to recognize plastics as something that is intimately intertwined in our economy. We are a petrochemical state. And if we don't do better with plastics, then plastics are in real trouble. And if plastics are so intertwined with oil and gas, then we're in trouble. So I think that, again, we have a lot to do with plastics, a long way to go, but we're on the right track. And eventually we will get there, sooner before later. And that's it. Oh, I hope I left some time.
Great presentation. Thank you. Do you have any questions for Maya?
Oh, I did a terrible job on time. I'm so sorry.
You're great. You're great.
Ta-da!
I think we'll be sending.
Yes, the question is, I'm supposed to repeat the question. Yes.
Yes, you
Where can I get a copy of this? Wherever you want it. You can write me, or you can, I'm sure these fantastic event organizers will
We
send
will
it
be
to the group.
posting the presentations that people agree to post. Yes. So, any other questions? Right here.
Sing out, Louise. The question is, yes, industries that need these materials back that are currently importing materials, wouldn't they support a DRS system? Yes. Yes, they do. In fact, the largest manufacturers of PET plastic bottles, aluminum beverage cans, and glass bottles all fully support national and state DRS systems. That's not the problem. The problem is the supply chain along the way, the brands. You don't know who Indorama is. Who's Indorama? Never heard of them. You've heard of Keurig Dr. Pepper, and you've heard of Coca-Cola, and you've heard of Pepsi. Those guys aren't sure. Now, they're not all against. They used to be, but now Coca-Cola National, which is an important distinction, is taking a stance that they're pro-bottle bill. They're sick of getting beat up by Greenpeace. But there is a Southwest Coca-Cola, and Southwest Coca-Cola is a subsidiary, but they don't listen to those guys nationally. Those guys, they don't want a DRS system in Texas. So there are so many stakeholders involved that you'd be surprised where, the opposition can stick a finger in your, you've hoped you've made a good sound structure. But they are coming around little by little, and sometimes one big swoop. But yes, the people who are making this stuff, who are on the hook from California and other places, they desperately want it back, desperately. Patsy,
Go ahead.
hi. Oh, that's such a great question, Patsy. To repeat the question, Patsy asked a good one, is how do we, the people, translate the rhetoric into political action? How do we take what we're doing and make action? Keep talking. Say it out loud. I know people always say, oh, social media. And I'm like so old, I don't even know, but it does work. I mean, I get comments all the time from some folks who say, well, I saw this tweet post about us and that's, we have goals and we do this, that, and the other. And it's like, oh, okay. But you read the tweet when someone was worried about you not doing that. And Greenpeace did a great plastic report that said, less than 5% of plastics are recycled. And the industry freaked out. Oh, that's not true. We do so much more than 5%. We do 7% this here, and we do 9% of this here. So yeah. I mean, all that stuff really does matter. It really does matter. So I would just say, start pinpointing, like when Coca-Cola National says we've got a great goal, maybe, hey, great job, Coca-Cola National. What about Coca-Cola Southwest? Yeah. Oh, great job, American Beverage Association, with your every bottle back. That's so adorable. What about in the 10 states that actually do kind of get close to every bottle back? And how come we can't have that in Texas? I've actually had industry folks who say, well, in California, we were supportive of SB 54. Yes, because it's California. But in Texas, we can't support source reduction in Texas. So why are we different? Why are we the pariah? Why can't we have our day in the sun? Ask those questions, ask them out loud. But again, let's not just be, we hate all plastics, because we have to be deliberate in our words so that our words aren't used against us. But yes, keep on shouting, keep on doing that research, and then tweet it out, Instagram it, all those beautiful, Facebook for the olds, all that has to happen. So yes, great job, Patsy, and great job continuing to do what you do. Yes, absolutely. The question was, should we contact our legislators here in Texas? Absolutely. They work for you and they really do listen. They don't always like to take the call, but they listen. And sometimes they'll have a little tally sheet by the phone. They'll say, hello, representative office. And you'll say, yeah, I really like this bill. And they'll say, okay. And they'll put a little tick mark down there. We got one support, one against. Those little tick marks matter. They really do. So absolutely, particularly around committee day. A lot of these bills, they might not get a hearing. The first one, it got a hearing. It's already out. We sure hope the second one gets a hearing. I don't know how many of the rest of them are going to get a hearing. In Texas, we got about 7,000, I think it's like 8,000 bills this session that get filed. And maybe around 1,000 pass, 1,500 ever pass. The system is designed to be hard, really hard. I know we have, 140 some odd days every 2 years, every odd year, which is appropriate. And my favorite joke also in the legislative saying, so it's supposed to be hard. And it is, it's hard. So if you get a hearing, boy, you're off to the races. So if you really care about a bill, watch for it getting a hearing. And if it does, you call everybody you know and their mother, and you tell everybody on that committee what you think about it, good or bad. That is really an important part of the legislative process, and they want to hear from you, and they should hear from you. They deserve to hear from you. So tell them what you think. Thank you, Patsy. Thank you, everyone.
Thank you. Excellent presentation. Thank you, Maya.
That's my email if you need anything from me. Thanks again.
Thank you. Well, you were great. You were great. Thank you. Okay. Our next presentation is quantifying tire wear particles on Austin, Texas roads, early insights towards an overlooked source pollution with Cole Carava. Thank you.
All right. Hello, everyone. I'm thankful to be here. My name is Cole Carava. I'm a senior at the Jackson School of Geosciences at UT Austin. I'm going to be sharing some work about my senior thesis, where I do concur that microplastics are the enemy, specifically these microplastics. These are tire wear particles. They come off your tires every time you drive. whether it's in a car, on a bus, on a bike. It happens. Everybody that came here today that wasn't walking or riding a horse contributed to this, but that's okay. It's just a big problem that we don't really know how to grapple with yet. But my research is focused on essentially trying to put a very preliminary number on the amount of microplastics generated at a few locations around Austin, around UT campus. So on a global picture, 460 million metric tons of plastic are produced in 2019, but tire microplastics that actually are plastics that actually reach the ocean, I should say, estimated to make up around 5 to 10% of that. But on a Texas scale, that's what this looks like. According to TXDOT, Texas Department of Transportation, and the Bureau of Transportation Statistics, we have millions of drivers, millions of cars. I didn't have to tell you that. Probably waited an hour of traffic this morning to get here. I did. But a lot of miles, 285 million to be exact, on the highway. That doesn't even include city miles. So this matters for a variety of reasons. PHAs, we've heard about today, PCBs, and metals such as zinc that are included in tire composition to, say, strengthen the tire or contribute to its durability. They can actually stick to the tire particles and form aggregates. And those metals have been, as well as the PHAs and PCBs, have been basically put in a lab scenario with organisms that like to live in sediment, and it has affected some of their developmental systems. And on top of that, other plastics have been shown to accumulate kind of similar to mercury across trophic levels. But for microplastics from tires, essentially they all start on the road. And you'll have plastics that come off of used tires that are like dumped in a landfill, but those don't constitute a large enough percentage. So for now, we're just focusing on microplastics that have been generated on the roads themselves. And they move through the soil, through the runoff, through the stormwater in unknown concentrations. And eventually some of those reach the oceans. But essentially for this project, we had very high hopes at first. We wanted to sample, kind of similar to some earlier talks today, a gradient from the road out to the creeks. But after looking into the literature and kind of understanding the uncertainty involved with this study, we decided to stick solely with the roads because there's enough going on there. On the diagram on the right, this is our sampling apparatus. Essentially, at 25 locations across Central Austin and around UT campus, I vacuumed the road shoulder, literally on a knee, vacuuming, and the airflow moved through. It's just a wet dry vac powered from a 12-volt battery for portability. And those filters are set in place, not necessarily to differentiate by size, but if I had used one filter, it would have busted through. So I kind of broke it up to promote longevity of my filters. All three of them were combined into one Petri dish by the end of it, though. This is a picture of what it looks like. This is the plastinator, as I like to call it. But once we had our samples, we put them through a JAMS device, and essentially the way that works is similar to Will Bailey earlier. It's actually, we're in the same lab group, so we use similar techniques for this part. And you put the lithium metatungsten in, and the plastics float up and the sediments float down. And on top of the plastics, you also get organics in that. And organics have proven to be difficult to differentiate from plastics in a lot of different studies that were mentioned today. So this is the LMT, and that's kind of what a day-to-day picture of the lab looks like. After everything was separated, we were kind of short on time, so we didn't get to do all the samples, but we went forward with digestion, as we like to call it, with hydrogen peroxide, and not the type of stuff you put on your knee if you scrape it. It's a lot more powerful than that. And Basically, it was used to dissolve the organic, say like cellulose fibers of the plants that you're found in the dust, or like I even found some insect heads that had been decomposed. It's kind of crazy looking under a microscope, but essentially those were burned down, or at the very least dampened, and they were the organic digestion lightened them. And according to the method that we used, which was ImageJ, I don't know if anyone here is familiar with that. It is software that's developed for counting cells or other biomedical purposes, but we kind of repurpose it to process our images according to color, because tire particles as well as bitumen, bitumen, if you didn't know, is it's a hydrocarbon that's used in asphalt production, and it's on roads, and it has similar compounds, and it also has been shown to have PHAs in it. So we kind of grouped them together for this. They have slight differences in their morphologies and their heat resistance, but for our purposes with this color, we couldn't differentiate, so we grouped them together. 2 thresholds were set on a 0 to 254 color ramp. All photos were an 8-bit. It was a grayscale image, if that's what that means. And essentially, we picked at random after doing some preliminary, not at random, that's a bad way to say it. We picked, after doing some preliminary work with the color ramp, we picked arbitrarily a low one and a high one. And essentially, the low was intended to only capture the darkest stuff, and the high was intended to capture also the dark stuff, but essentially it encapsulated some of the organic material that didn't get dissolved. And I should note that on this method was used on all of the samples, not just the ones that were digested. This is kind of an example of what it looks like. You have a filter that is vacuumed through and it's separated, and this is thrown into the software where the color threshold is set. And on top, I mean, once that's good, there's a process called edge. You find an edge, and all of the grains that meet that threshold or underneath it are accepted and recognized by the software. And that's a difference between the thresholds. So you can see a significant amount of particle increase on the right. That's not to say those are all plastics, because those also include the organics. This is a map. It's very primitive. We're still working on the paper and the specialized figures, but essentially these were our sampling locations. You can see A locations are busier, for instance, near Airport Boulevard or near Redbud Isle Park. Basically faster moving thoroughfares with around 45 to 50 mile per hour, sometimes still in the 30s speed limits. The red locations are B locations, and they mostly made up neighborhoods. And they were much quieter, much safer. Some of the work when I had to go early in the morning or late because the roads were pretty busy, and the road shoulders sometimes were not very wide. But going forward, this is some figures from the 70 threshold, which, if you remember, is the low threshold. This is what we said was tires and bitumen and not organics. This data is from all of the locations that were not digested. Excuse me. They were not digested with H2O2, but as you can see, in a square foot of sampling area, which we did because the best vacuum nozzles that we were able to find were 12 inches. And it was very simple to just vacuum for a foot. So we have a square foot, but within that square foot, we solved and figured out that 3395 and 2834 were our numbers of particles registered as tire plastics. Keep in mind on this filter, I noticed it basically on the way here yesterday. The scales are different. So the B locations had higher counts. this is an example of what it looks like, a filter with the edges outlined in red. And this is the filter in the grayscale. As you can see, the 70 threshold didn't work as well as we had thought. It didn't take the edges correctly, but it did do a better job of not selecting the lighter grains. That was a good aspect of it. We found that it took it differentiated between the light and the dark better than the 150, but for the bigger grains, it just didn't retain the integrity of their edges. But at A3, which is one of the ones that was digested, we counted 3,600 particles, or I didn't count, the software counted, and a mode of 180 microns basically means the most common grain in there is 180 microns and of a diameter. And oh, sorry, I misread that. The mode is 88. The average grain size was 180 microns and the most common was 88. On the other hand, the 150 produced some really interesting results. A lot of the small grains were actually incorporated. The larger grains had more integrity on their boundaries, and I think represented a more accurate classification of all the grains. It does include organics at this point because the H2O2 didn't do a perfect job of getting rid of them. But as you can see, the statistics slightly changed. The mode was much smaller because you have so many of these little grains actually being counted. And all of these particles were essentially that didn't show up on the 70 threshold, showed up on the 150. So still writing, still gathering data and analyzing our results, excuse me, but we do have some interesting results as of now. At the very least, we know that tire particles and bitumen particles exist in hundreds to tens of thousands, potentially hundreds of thousands on all of our roads. You have to keep in mind, I forget sometimes that all these concentrations that I measured was just for a square foot. So if you multiply that out to how much road we actually have and how much is being potentially run off into the waterways, the numbers get big really quickly. Particle size checks out with a lot of the literature. Average grain sizes were a little high in the 180, 170 range microns. But as for the mode, a lot of the literature says that road particles and tire particles like to sit around 75 microns. After doing my work, I think it should be noted that as you increase magnification on the microscope, they just keep appearing. So there's plenty of even probably sub-micron particles out there that this method is not usable for. But the ImageJ is promising for future use, and it really sped up the process of counting these filters, because initially we started manually, and like others have mentioned today, it takes several hours, and your eyes feel like they're about to fall out of their head. But anyway, this technique we switched about halfway through and then redid everything, and I think it's going to be very promising going forward. A better threshold is necessary. We set our 70 and 150 arbitrarily. I would say if I was going to do this again, I would do somewhere in the 130 range to where it retains more integrity, but it doesn't include some of the darker organics. And this walking this line is going to be the way to perfect this technique. It is unfortunately limited to tire particles because it goes off of contrast and lighter microplastics won't be registered. But I think that this technique is at least a good start in getting an idea of microplastics that come off of your tires. So anyway, that's what I've got so far. We're still working, but I'm very thankful to be involved with it. It's been exciting, and it's been quite a ride because we initially wanted to quantify microplastics, and it ended up being more of a fight to figure out the method and establish a better method, because methodology in this field is still uncertain, and people have not decided on the best way to go forward. But anyway, my advisor Cornell has been a huge help, and I'm very thankful for Will also, because he's been a mentor to me over the last couple of years. We're in the same group. So anyway, and my Aunt Kim also has helped me a lot. She works at UC Irvine in anthropology. But yeah, that's it with that. I'll open up to questions. Thank you.
Okay, thank you, Cole. We probably have time for one question. Anybody has anything? Go ahead. If you can repeat the question before you answer.
Right. So the question was about how to differentiate between bitumen, asphalt particles, and tires that are generated. In this specific technique, we were not able to differentiate based off of or based on where it comes from, because it's based off of color. Doing a visual analysis, you can tell because the bitumen particles are more blocky, and they're the tires are, my advisor Cornell calls them alien grains. Their morphologies are super irregular, and you could tell pretty easily. But with this technique, it's hard to differentiate the count. But it's definitely some of these that we studied are certainly from the bitumen and not from tires. But since they contain similar toxic compounds, we kind of grouped them the same way.
Okay, thank you very much. Great presentation.
Thank you.
Okay, up next, we have Upstream Plastic Pollution and the Myth of Chemical Recycling by Jennifer Hadaya. Really? Yes. Oh, thank you.
I see a little formatting that went off there. Thanks so much. That was perfect. Yes. Rarely first out of the gate, Hadaya gets pronounced correctly. So this is exciting. I am taken back to my time at HSPVA back on stage. This is amazing, y'all. So honestly, I couldn't have asked for a better setup to this presentation than our fantastic keynote speaker, because I believe she was absolutely right in planting a seed of doubt in everybody's minds here in this auditorium today about chemical recycling, or what I like to refer to as plastic burning. Not so much because what we don't know about the process, but because of what we do know about the process. And that's what I hope to share with y'all today. And in full transparency, if a year ago at this symposium, I wouldn't have been standing in front of you with this presentation, because I myself was unaware of what was happening with the process of chemical recycling, not in a theoretical sense, not in a what could be sense, but in a reality right up the road, right in our backyard sense, because plastic burning is happening as we speak in the Houston area, and there is more coming. And so I thank you for the opportunity to share this information with you today. I do so on behalf of my colleagues and sibling organizations. I work for Air Alliance Houston. I'm here presenting on behalf of Michael Lewis at Environment Texas and my colleague Naomi Yoder from Healthy Gulf. And Naomi is also here in the audience today. So I encourage you to reach back out to either one of us with questions or comments after you hear this presentation. I do have a disclosure. It's a really big one. My disclosure on this presentation is that we're advocates, right? I'm not a researcher. I'm not a scientist. I know this got grouped under like the section called, chemicals. I'm not a chemist. Trust me. What we are advocates. And I am an advocate for two things primarily, one for clean air and one for environmental justice. And the issue of chemical recycling, or AKA plastic burning, is an issue that crosses over both of those things. And that is what I would like to talk to you about. And because this is an advocacy presentation, I am here to try to change hearts and minds and activate you to take action and become advocates for yourselves for those two things, clean air and environmental justice. So let's start with some fun headlines. These are headlines that you will see throughout the Houston region. Most of these headlines center the needs of the oil and gas industry. Y'all may know right up and down the ship channel here in the Houston area, we have legacy oil and gas refineries. These are refineries that have been here for over 100 years. They are visibly rusting. And we have forces at play that are making the fossil fuel industry quite nervous about what's going to happen to those legacy refineries and to their upstream and downstream business. And so you'll see headlines like this that have come out that have said, look, you, the consumer, oh, is this it? Yeah. You, the consumer, are demanding this from us, right? You, the consumer, need us to burn your plastic, and centering it as that economic revolution for how we can turn that rusting legacy oil and gas refinery into something that will make more money. So as our keynote speaker said, I hope you will hear me when I say plant the seed of doubt when you see headlines like this about who they are centering in the headline, because these headlines are centering a theoretical downstream solution to keep the upstream still pumping and fracking and sending out oil. Let me show you some other headlines. I don't think we could have an event today without acknowledging the environmental and human disaster of what happened in East Palestine earlier this year. Why did that happen? The chemicals that were being transported by that train are directly related to the production of plastic. Y'all probably know about that. There's the chemist and the scientist, the vinyl chloride. But the false solution, I believe, of plastic burning to maintain an upstream industry that churns out more products based on oil and gas is allowing more pollution to come into our community and more potential for disasters just like this. Disasters that happen also very close to home. We had a chemical related fire at a facility in Pasadena just last week. This is happening right here in our backyards. So let me tell you a little bit more about what I do know about plastic burning. Here's the most chemical scientist researcher slide I'm going to show you, and I'm going to go over it really, really fast because it wasn't one that I created. I am indebted to Dr. Singla for creating this. This is just the 101 of what chemical recycling is. It is in its simplest form, taking plastic waste, breaking it down with various processes, and sometimes turning it into fuel. That's not really what's happening in the Houston area right now. Otherwise, it's breaking it down into teeny tiny parts and then turning it into something else that is another form of plastic. Whew, that's the most scientific I'm going to get. Let me go back to this slide. What do we see as what chemical recycling is and isn't? So what it is, it's a new mechanism for basically an old and dirty process. We've been breaking down plastic into tiny, tiny, tiny pieces for a very long time. What our keynote speaker rightly said is that we just have these new terms for it. So now we're calling it advanced recycling. That sounds really good, right? Or chemical recycling, which differentiates it from what it really is, which is basically burning plastic with chemicals. So it's just a new term for an old process. It's also a major investment by oil and gas. As I've said already, oil and gas companies like the ones I'm going to show you in just a moment are investing in these legacy, aging, rusty facilities and turning them into plastic burning facilities so they can keep that process going. So it's a major investment to transition oil and gas away from those things that we as a culture and as a society are needing to move away from due to issues around climate change. It's unsupported about its claims to success. Absolutely true. There's a lot we don't know. There's too much we don't know about this process and whether it will produce on the promises that are being made for it. And it's embraced locally here in the Houston area by facilities that are already historically very bad actors in terms of their pollution to our land, water, our air, water, and soil, and to their impact on fence line and frontline communities. So what it isn't, we don't believe it's a green solution to the plastic crisis. We don't believe it's a way out of the reduction of plastic dependence because it doesn't do anything to the upstream supply chain. It just burns everything in theory that we are still producing. It doesn't do anything to stop the flow. And it's not true recycling, meaning that what goes in comes out in a consumable, usable form. That has not been proven to be the case yet either. All right, so here's what we do know. This is a study of multiple air permits of several different chemical recycling, AKA plastic burning facilities across the country, and a summary of all of the chemicals that are produced when the plastic is burned. So we know plastic is burned. We know that's the process. We know that there are things that happen when that plastic is burned in these facilities that are being converted or built for this purpose. And these are the chemicals that are released in that process. I'm sure everyone in this room knows these are not good things, right, to be emitted. These aren't what we want out in our air or in our water or in our soil. And these are the reasons why. These are all of the chemicals that are produced during plastic burning, and these are the downstream health impacts in almost every system of the body that these chemicals are known through decades of research to directly or indirectly contribute to, cause, effect, upstream cause plastic burning. So this is something we do know. We know this happens. We also know that this is one of the major proponents of plastic burning here in the Houston area. We all know this company, right? ExxonMobil is also the largest contributor to heat trapping gases in the Houston area. They also have had multiple incidents at their facility, including a fire just about 2 years ago, right before the year end and Christmas holiday, sorry. And we know that this is the type of facility that is embracing chemical recycling as a way to maintain their facilities on top of the air pollution and chemical related emergencies that they have already caused. So let's talk a little bit about ExxonMobil as a case study. So these are some data about ExxonMobil. Thank you to my colleague Naomi Yoder for putting this together. We know that there are at least 32 different hazardous air pollutants that are released within the permitted limit of this facility. But we also know, because of a very lax regulatory environment in Texas, that most facilities, including Exxon, don't release only within their permit. They release outside their permit. They release fugitive emissions. These are emissions already happening, not even including what is going to be there once their chemical recycling facility is completely up and at full capacity. These are the kinds of pollutants they are putting out, and these are the number of excess pollution incidents that are occurring, how many releases are occurring, and the amount of air pollution they're putting into the air. So this is the kind of facility that is embracing chemical recycling as their solution to meet your consumer demands for recycling single-use plastics. This is the kind of facility that's embracing this technology. These are the environmental justice considerations for these facilities. So it is not common that facilities that produce air pollution and that are also subsequently embracing chemical recycling are in neighborhoods that are of high wealth, that have considerable political power or otherwise. It is most often the case that those facilities are located in communities of color and communities of lower wealth that, for historical and deliberate policy reasons, have also been disenfranchised from power. This is another study, again, from my good friend, Dr. Singla, that looked at several chemical recycling facilities. All of these are chemical recycling facilities across the country. You'll see them in different states. And an analysis of the demographics of the fence line and frontline communities that surround these facilities. You will see over and over again that these communities, again, are people of color and of lower income that are now being increasingly harmed by the additional air pollution that comes out of chemical burning, on top of the air pollution that those facilities were already putting out, and putting them in potential harm's way for another East Palestine level disaster because of the chemicals that are being used and transported. This is across the country. Let me show you what's happening up the road. There's a phenomenon in the Houston area that we call the Houston arrow. It's literally an arrow on maps that look like this, where we overlay environmental harms with social vulnerabilities like demographics of race, ethnicity, income, language, sex, etc. And what starts to show up every time you create these maps is an arrow, a literal arrow that points. And in this map, this is a map of race, ethnicity, and locations of toxic releases. These are all of those refineries and visibly rusty facilities that are there currently, and the two proposed and existing chemical recycling, aka plastic burning facilities. There's Exxon, there's LyondellBasell. Those are the two facilities. Exxon is currently active. It is operational. Lyondell is supposed to be coming online by the end of the year, both of which claim to be plastic burning or chemical recycling facilities in the long run. And what you'll see in the Houston Arrow map, here's the arrow right here. In this particular version of the Houston Arrow, the arrow is showing you communities in the Houston area by zip code that are not communities of color and are not low income. So this is an arrow of people who are basically rich and white. And that arrow points to the rest of the community, which tends to be of color and lower income. And so you'll see where many of these TRI facilities and the new chemical burning facilities are located. They're not generally located inside this arrow. They are located in those places where historically and deliberately property is cheaper, people are more disenfranchised, don't necessarily know that they can speak up against these facilities and stop their communities from being harmed. Let me show you the arrow much more shockingly in this one. Do you see it? So here's the arrow. This is income. So here again is the wider, wealthier part of Houston, pointing at the areas that are lower income, people of color. Again, you'll see all of these TRI facilities and the 2 new facilities that are being proposed for chemical burning. So there is much we do not know about chemical recycling in the Houston area, but we absolutely know that the 2 locations being proposed for this are already in communities that are overburdened by air pollution and the potential for chemical disaster. So if I could leave you with 3 things today, remember, full disclosure, this was an advocacy presentation. I was here to change your mind. If I could leave you with 3 things today, it would be these 3. Number 1, call it what it is. Advanced or chemical recycling is not new or green. It's another name for burning plastic. Now, what some of my colleagues in the environmental justice movement will also call it is false recycling, because again, it doesn't actually produce true recycled products either. It simply burns the things we have and in the meantime, pollutes our air, water, and soil. Look for the sacrifices. So in any study, new technology or mapping, ask yourself, where is the sacrifice zone? Where are the communities that are being subjected to environmental harms in this picture? And in our picture, the locations of the facilities are already in overburdened communities of color and lower income. And the facilities embracing the technology are themselves bad actors. They're already breaking the law by emitting beyond their permit. Why would we allow them to emit more? And then last but not least, probably don't have to tell anyone in this room, this one, follow the money, right? We need to continually question the viability, benefits, and risk of a process embraced by the petrochemical industry that is struggling to keep itself alive. And with that, I thank you for giving me this opportunity here today to try to change your hearts and minds. And I welcome any questions for myself or my colleague, Dr. Yoder. Thank you so much.
Thank you, Jennifer. Okay, any questions?
And I can't see y'all. This is very disconcerting. I really literally like can't see a single face in the audience. It's very odd. It's like Zoom, but in real life.
Right up here?
Question was, I recognize that voice though. Are there any existing efforts to curb or prevent the opening of the Lyondell-Basell plant? Yes, there are. There are the beginnings of a working group that involves my organization, Air Alliance, Environment Texas, Healthy Gulf, the TSU Bullard Center for Environmental and Climate Justice, and several others who are starting to come together to identify how we can make change in regards to the opening of the new facility or to the expansion of the Exxon facility. Fun fact, there is a program in the Houston area called the Houston Recycling Collaborative. You may have heard of it. The Houston Recycling Collaborative was created through an MOU between the city of Houston, Lyondell-Basell, ExxonMobil, and Cyclix, which is another company that plans to bring online chemical recycling but isn't there yet. And it's a commitment from our municipality, the city, to send municipal single-use plastic to those 3 locations for them to burn. And it is, in our opinion, the basis or let me say, the beginning of, and maybe the basis for this new industry coming into the Houston area. We are working in that work group to oppose that MOU, bring it to light, and say to our municipality that we as I live in the city of Houston as a taxpayer. I'm uncomfortable with this arrangement because it is using taxpayer dollars and supporting a process that is harmful to the community and has environmental justice considerations. So the Houston Recycling Collaborative is the same thing as chemical recycling in the Houston area, one and the same. They are not different. They are the same thing. So that may be, fun fact, eye-opening to put those two pieces together. I don't know if those facilities would have happened without the MOU, but they are definitely happening with it. I think another consideration that our working group is looking at is air permitting. How will the permitting be affected? Will it be separate from, will it be in addition to the current air permits that these facilities already have? We at Air Alliance Houston have a very robust permit opposition campaign currently to try to hold facilities accountable when they exceed their permits, to give them time for impacted communities to look facilities in the eye and look TCEQ in the eye and say, look, you're here to protect us, not to protect industry. And we will fold the chemical recycling permitting process into that industry opposition campaign work. So if you are interested and want to get involved in this work, I welcome people to join our working group. We are getting off the ground right now. It took legal action for us to get a copy of that MOU. That makes me scratch my head a little bit. But we are trying to learn more. We want to learn more. We want to hold polluters accountable. And we want to protect our communities of color and lower income.
Thank you.
Thank you. Thanks, everyone.
Thank you. Okay, our next presentation is by the Dickinson High School Aquatic Science class, Environmental Improvement Efforts. I will let them introduce themselves.
Hello, my name is Taylor Williams.
I'm Gabrielle Becker.
Jackson Colton.
I'm Kaylee Hernandez.
I'm Peyton Landell.
I'm Avery Manassi.
I'm Layla Jackson.
And I'm Mark Villarreal.
And we are here today because Dickinson High School has been a holder of the NOAA grant for 5 years. The beginning efforts were made internally around the school. We built reusable fountains to reduce the amount of plastic water bottles in the environment. Now we are taking charge and informing the public about the issues within our communities and oceans and local watersheds.
NOAA is the National Oceanic and Atmospheric Administration, founded October 3rd, 1970. Our local office is the Flower Garden Banks National Marine Sanctuary located in Galveston, Texas. I call NOAA our oceanic police because they are constantly creating new policies to better our forever changing world. Their mission is to understand and predict changes in climate, weather, ocean, and coast, as well as to conserve and manage coastal and marine ecosystems and resources. They work to share knowledge with others and to better understand our constantly changing environment.
What is the Ocean School Guardian Grant? It is a grant program funded by the National Marine Sanctuary Foundation and managed by the NOAA Office of National Marine Sanctuaries. The program furthers the educational goals of NOAA by supporting hands-on projects in K-12 public, private, and charter schools. They have different project pathways. There is watershed restoration, the 6 R's: refuse, reduce, rethink, rot, recycle, reuse, the schoolyard habitat and garden, marine debris, energy and ocean health. Our school has the marine debris project pathway, which focus on reducing single-use plastics and promoting the use of reusable water bottles.
Okay, so our local impact. We have been a part of the Ocean Guardian School since 2018. The grant has provided water bottle refill stations located around campus, reusable water bottles for aquatics and IPC students, field trips, and guest speakers who come in and speak to students. They have also donated $18,000 to help us carry out our plans to better our community and spread word.
So why Dickinson High School?
Dickinson got this grant to carry out our own school and community-based conservation projects that make a difference in the health and preservation of our local watersheds and the world's oceans. The purpose is to protect the oceans and watersheds for the future generation and to educate the youth about different environmentally sustainable practices. Our school is working towards the goal of preserving the oceans for the future generations.
Hello, my section is about plastic and how they affect our ecosystems. First, I want to get into the process of which plastics are formed. It includes 4 different steps. The first step, where raw materials are refined into propane and ethane. The second step, both materials are turned into ethane. This step is usually broken down and known as crackling. The third step, both substances are combined, and in the fourth and final step, the polymers are made for the plastics to form. This process costs us of using many different fossil fuels, which are crude oil, natural gas, coal, and plants. There are many different companies that make plastics, but the 3 largest companies are London Basel, DuPont Incorporation, and Dow Chemical. Next, oh, snap, hold on, I forgot about my fault. Next is about single-use plastics, which are plastics that end up in our oceans that are man-made and take hundreds of years to break down. We find so much in our oceans and waters due to how easy and cheap they are to get a hold of or lose track of. Many people use them for packaging and serviceware like water bottles and straws. A lot of people want to ban these plastics due to how harmful they tend to be in our environment. They take fossil fuels to produce, and when they start to break down, they release toxic chemicals that release into our oceans. And next, I want to talk about nurdles, which pretty much everyone in here know what they are and pretty much knows what they are. But nurdles are small plastic pellets that come from the raw materials that end up in our oceans and waters. Nurdles end up becoming a huge problem due to how tiny they are. Humans tend to forget about them, and they add up, and aquatic organisms misjudge these pellets for food, causing them to die from starvation with a full stomach of plastic.
Hi, everyone. I'm going to be telling you guys about the negative impacts of marine debris and plastics. So why is marine debris harmful to the environment? Marine debris can injure and kill marine and coastal wildlife. It can also damage and degrade habitats and cause economic loss to fishing and maritime industries. It also degrades the quality of life in coastal communities and threatens human health and safety. So how can marine debris be harmful? Ingestion and entanglement are 2 very harmful effects of marine debris and plastic. Ingestion is the process of taking food, drinks, and in this case, any other substance into the body by swallowing or absorbing it. If these objects end up inside of an aquatic organism, it can cause an infection and lead to internal bleeding. Entanglement occurs when fishing gears and marine debris wrap around an animal, weighing it down, restricting its movement. This often leads to death and other serious issues. Next, we're going to talk about the chemical effects marine debris and plastics have on human health. Plastics have a number of effects on human health. For example, endocrine disrupting chemicals known as EDCs. This can be linked to infertility, obesity, diabetes, prostate and breast cancer, along with many more. This can also cause health conditions linked to additives like reproductive growth, cognitive impairment, and neurodevelopment disorders, which is when an individual has trouble remembering and learning new things. To put this into context, scientists have estimated that the average person might eat 5 grams of microplastics in a week, which is about the weight of a credit card. This equals up to be about 52,000 particles annually that we consume unknowingly. Next, we're going to talk about how plastic waste links to fossil fuel use and climate change. They represent a direct negative feedback, such as fossil fuel-based plastics causing a direct emission of greenhouse gases throughout their life cycle. Plastics are a part of a sector called petrochemicals, meaning that they are mostly made out of oils and gases. This means that most corporations make plastics out of dirty fossil fuels. And a little fun fact for you guys, it's about whales. Every year, 300,000 whales, dolphins, and porpoises get accidentally entangled in nets and lines, and they die a very slow and painful death through suffocation, starvation, and exhaustion. So please think twice before you're responsible for causing all these negative impacts to marine environments. Thank you.
So for my section, I'm going to be talking about the refillable water fountains and what they are. So refillable water fountains are stations that sanitize tap water for the public where people can refill their bottles. Each station has a counter on the top of the fountain that counts the amount of water bottles filled in 16 ounces, as demonstrated on my 3D model here and up there in the green. So where are they located? The refillable water fountains are located in many public establishments, especially where water bottles are often used, such as parks and schools. There are 13 on our DHS campus. And why we use them. NOAA gave us these water fountains to use them to reduce the use of single-use plastic water bottles and encourage people to refill them instead of trashing them. And they also give us public access to safe and clean drinking water. So on this next slide here, we have the statistics for each location and their impact. These refillable water fountains are major long-term investments. They cost $1,500 per station, but tap water is approximately 500 times cheaper than bottled water. So the amount of plastic being saved is exponential. As of January 27, 2023, DHS has saved approximately 209,267 water bottles across the campus and will continue to do so.
Hi there. So I'm going to be telling you about another component of our NOAA grant in helping us reduce single-use plastics. So what are these? These are the reusable water bottles that we've distributed at Dickinson High School. Reusable water bottles are water bottles with the purpose of being refilled, washed, reused, and they're usually made out of hard plastic and metal. These bottles shown here were distributed to Honors Aquatics and IPC Science students at Dickinson High School through the NOAA grant. And we have these to help students, to encourage students to help reduce their use of single-use plastics. And we also, not only to the bottles, we also provide stickers to students that they can put onto their reusable water bottles if they already have one. So the statistics on these. So although single-use plastics are convenient, they have a great cost. The US alone uses approximately 17 million barrels of oil annually just to produce plastic water bottles, which could actually fuel about over 1 million cars per year. And not to mention the negative impacts of the carbon and fossil fuel emissions on the environment. Additionally, the EPA approximates that we only recycle about 25% of our plastics, and that's including combustion recycling. Additionally, tap water is only about $2 per 1,000 gallons, whereas individual bottles can cost up to $6 each. So not only are you saving the earth, but you're saving money too.
The big question: why did we spend 4 days cleaning up marine debris along our local coastlines? We did this to learn about different concentration of debris along the coastlines to prevent entanglements and ingestion of our wildlife, as well as their habitats, and to spread awareness around our school and prevent further pollution.
We also do beach cleanups due to its benefits, such as data for research, makes the coastline beautiful, spreads awareness, lessens the debris, provokes change, people become more involved, prevent endangerment, make the ecosystem healthier, and better the conditions for both humans and marine life.
Here we have the data of all 4 days of the beach cleanups. On the first day of the Monument Inn in LaPorte, we collected 1,062.93 pounds,
which is 38.1%.
On the second day at the same location, we collected 504.75 pounds,
which is 18.1%.
On the third day at McBride Boat Ramp in Baytown, we collected 145.14 pounds,
which is 5.2%.
On the last day at the Texas City Dike, we collected 1,076.84 pounds,
which is 38.6%.
In total, our classes collected 2,889.66 pounds,
which is our total of 100%.
The reason why day one has such a high number of debris collected is due to a group of boys finding a 500-pound road sign on shore and carried it all the way to the trash. The third day has such a low amount due to a smaller group of students volunteering on a course a Saturday. Why would we want to reduce stormwater runoff? Firstly, what is stormwater runoff? Stormwater runoff is a mix of precipitation, suspended sediment, debris, and chemical pollutants, which can cause pollution in our waters from the dirty debris and other chemicals that may have floated with it. Flooding, which would be caused by said debris and cause damage to public and private property. Eroded stream banks that is caused by the sediment clogging waterways, fills lakes, kills fish and other aquatic animals.
A way to reduce stormwater runoff is rain gardens. Rain gardens are gardens that filter polluted rainwater into clean groundwater that helps reduce stormwater runoff. Rain gardens consist of soil, mulch, rocks, and plants. We also have a cistern tank and salvic system, which works with the rain garden to provide a clean water source for later consumption. Here is Dickinson High School rain garden and cistern system. And this is also extra information about what the rain garden would look like in the future, as well as the location it is on our Dickinson High School campus. And that is Dickinson High School making change. Is there any questions? Oh, you there?
There we go. Good. Any questions?
Any other questions? Oh, one up here?
The plants that we used is plants that are native to brackish water. Having native plants helps the water flow. Any other questions?
Okay, great job, guys. Thank you very much. Okay, our next presentation, Born on the Bayou, Marine Debris Distribution and Composition in the Galveston Bay Watershed with Amanda Hackney. Good job, guys. Nice job. Good job. Thank you.
All right. Think I've been alluded to a couple of times today. So I hope I live up to your expectations. I don't know. Yes, my name is Amanda Hackney. I work as a contractor, own a company called Black Cat GIS. Today's program that I'm talking about is the STOP program. We are currently contracted to Keep Texas Beautiful, who received a grant from the EPA's Clean Waters Act. And this project has been supported in the past and is still being supported by the Garver Black Hilliard Family Foundation. So let's get trashy. So you guys know the cycle. I'm not gonna go over the cycle. Feral trash escapes, it gets into the water, it becomes a problem, right? And in our part of the world in particular, it becomes a problem in regards to flooding. We see a lot of little log jams that are not made out of logs. They're made out of plastic water bottles. So this project set out to determine the what, the where, and the why. What is the composition of litter? Can you comfortably go to a city council or to, I don't know, Texas State Congress and say, this is our problem item? So we didn't have that information. We wanted to know about the where. Where are my hot spots? Where is litter starting to pile up the worst? And we wanted to know why, but I didn't have enough funding for that. I don't know if all of us together have enough funding to figure out why littering is happening so much. That belongs in a human behavior course. So we're gonna skip that one for now. So from that project with our EPA funding, we wanted to promote the use of the STOP program statewide. And we wanted to encourage the use of the Texas Litter Database, which has been presented on earlier by Aaron. Hi, Aaron. And we also want to develop a spatial model of the lower Galveston Bay that takes in a bunch of different variables to predict hotspots, combine that with our survey data, and start to try to map these areas across the watershed. So what is STOP? I don't know. I've just been saying STOP for a while, whatever. So STOP stands is where we are doing essentially when we used to do vegetation sampling and you threw down a square, instead of counting every single grass in that patch of prairie, you took a little subsample, right? Same thing. We're taking a little subsample of trash. So we tell folks to measure out a transect. We start at 100 foot. And depending on how bad the trash is in that area, you may want to expand or decrease. We pick up every single piece of trash along that transect, anything bigger than a cigarette butt. There are tons of folks doing great work on microplastics, and I don't like to wear my glasses in the field, so I don't do micro stuff. We then count and tally the items. We've got a good data sheet. We spread everything out, and we make it kind of a bonding experience, me and the interns. And we just sit there and we're like, all right, add 5 more plastic bottles, add 2 sporks. I didn't know if I was saying spoon or forks there, but it doesn't matter because it's a spork, right? And then we record the information in the Texas Litter Database. That top picture is kind of a typical transect. That is right on Brays Bayou where it hits Buffalo Bayou. One of the things we have found is where you've got those intersection of waterways and water's kind of moving back and forth. Always, always, always a hot spot. So to do this, as part of our contract with KTB, we wanted to get out and we wanted to get volunteers involved. We wanted to get folks trained. Let's go do science. Let's not just gripe about plastic. Let's go out. Let's do science. We'll take it to the politicians later and they'll pass laws and everything will be great. We're still working on that last part. But so we wanted to target groups that everyone knows and loves, like the Texas Master Naturalists. We worked a lot with Keep Texas Beautiful affiliates like Keep Dickinson Beautiful. We've worked with Keep Austin Beautiful. This is a statewide program, the STOP. So while what I'm showing you today is just the Galveston Bay area, we've talked to folks all across the state. We did some webinars, including some for Texas Children in Nature Network. We had volunteer databases that we kind of borrowed from partner organizations. You know, just reaching out to folks and say, hey, we're going to have a training. Come do this training with us. We'll show you the method. We'll pick up trash. It'll be great. And we also targeted some Facebook groups. We attempted to do a kayak cleanup on Buffalo Bayou there around Turkey Bend. And we also tried to target high school kids who need service hours and were interested in a science activity. I will say one of our good ways to get the word out was at the Keep Texas Beautiful annual conference. Last year it was in Austin, and we gave a very long talk on data and why you should collect it and why it's important and why you need to be excited about it. This year, FYI, pull out your phone, put it on your calendar. It is in Houston. It'll be June 26th through 28th. So if you're interested in that, I believe they have openings for tables still. So do some vending with a new group. So that was all. It looks great on paper. It looks great on that slide, but we had some challenges. First of all, we didn't have great turnout. We'd say, oh, let's come do this training with us. It's going to be at Challenger Park. It's going to be here in the Woodlands. Come out. And I don't think people completely understood what we were trying to do. So we also, when we picked a weekend, I swear we had the worst luck. Never try to schedule something on Earth Day weekend, y'all. Everybody and their mother's doing something, and volunteers are hard to come by. There was also a little confusion in what we were doing, which is more research oriented, with other groups, which were more removal, doing the actual cleanup. So we needed to we got some feedback and we started to clarify our message a little bit better. We had a little difficulty with figuring out our best target marketing materials. We figured you guys all are suckers for stickers, as most of you have probably stopped by the table today. But we're working on developing more online material and just trying to get the word out. And also the concept's kind of a hard sell. Let's go to a stinky bayou that's kind of in a sketchy part of town, and let's dig out old dirty diapers. And then we're going to pour it out in a big pile, and you're going to pick through it and write things down on a piece of paper. Who's ready to go? But there were some good things that happened as well. So we had our best success at booth events or doing trainings at an existing event. We would kind of crash and slink around other people's cleanups and be like, hey, can we weigh your trash bags? Like stand by the trailer and be like, wait, I'll get that for you. So we would show up, we would do a transact for folks. We would share the transact data with them later, whoever was organizing the cleanup. Basically, we were just sponging off of them like one of those little remoras you see sticking to a shark. We had a lot of success talking about the data with groups. Instead of talking about training and going through how exactly you do these things, we would go to a KTB affiliate or Master Naturalist meeting and be like, look at all this cool data. Isn't it amazing? Look at this map, pretty colors. Oh, do you want to help with this? It'd be super cool if you did. So that went a little bit better. Once people understood what we wanted the data for, everything was good. And we also did some partnering with local colleges to enlist college students. As someone who has taught college courses, if you offer bonus, you can get kids to do a lot of things, especially about this time of year before grades are coming out. So as I said, all of this goes into the Texas Litter Database, all of this data that we're collecting. And that is indeed the central state database. We're taking all kinds of data. If you got TxDOT methodology, if you've got NOAA methodology, put it all in. It's available for anybody to download. There are charts and maps available as well. So this is txlitter.org. Told you we were going to do the spatial model. I really wanted to show you the spatial model. It was going to be so cool. I'll show you that in like a month and a half. Okay. Things have been, we keep seeing more things that we need to put in. These are just a few of the variables that we're putting into our spatial model to see if anything starts to show patterns that we can then use to predict where our hotspots are going to happen. So just a brief subset of the data. I pulled about 200 Transact surveys. I normalized them. Some of them were 100 meters. Some of them were 100 foot. There's a infamous 2-foot that was done out at Monument Inn because I did not want to pick up that much trash that day. And of those 218 surveys, and when I say normalize, I calculated the trash per 100 foot, no matter what the distance was. There's some percentages of bottles, but best way to normalize. We ended up with 146,000 items, including fragments, in those 218 surveys. That's approximately approximately 700, you want to round up, items per survey. Just a couple of highlights because I'm running real short on time. These are our broad categories, so all of our hard plastic items. This is how many things I can expect to pick up in a 100-foot transact on average. 300 parts plastic bottle, 86 pieces of styrofoam, 210 bits of film, and about, again, 670 total. On a couple of our individual items, I popped those on there. On average, in 100 foot, I can expect to find almost 13 plastic bottles, about 30 container caps, a couple other highlights there. I am so tired of Cheeto bags, y'all. You have no idea. Food drink wrappers, I can always expect to get about 11 of those. So we've got this data again available. The final report will be coming out by the end of June because that's when my funding's done. Just looking total, as you guys know this, most of my problem is hard plastic. After that comes film. I will say that film and styrofoam are probably very underestimated in this just because of the nature of how it breaks down in fragments and it's difficult to count. This is what we're eventually going to make. I'm out of time. So I'm going to be like, look, wait, there's more. Next year, I'll show you these things. And we're finding some good correlation with high litter amounts and rivers and waterways. If you're interested, if you want training on STOP, go to our website, blackcatgis.com/stop. And I've got a form there that you can fill out to ask us for more information. Or you can, of course, go to the litter database website, txlitter.org. And with that, I've run over time, but get us some data. I don't care if your data is in a different format. Talk to me. We'll figure it out. I'll make Erin help. With that, questions?
Thank you, Amanda. Okay, any questions for Amanda? Everybody's gonna go give her their data, right?
Also,
Okay.
we still have stickers.
Cute stickers.
They're really cute.
Cute stickers.
But you have to come sign up for the database, and I am too lazy to email you once a month. So you're looking at maybe 2 emails a year if you write your name on that and you get a sticker. So yeah.
Thank you, Amanda. Okay, the next presentation is Making a Splash. Bird conservationists addressing the threat of plastic pollution with Celeste Silling and Chloe Dansville.
Gosh, it's great. Oh my gosh. Look what I got that. I got this already. Hi, everybody. My name is Celeste Stilling. I work for Gulf Coast Bird Observatory and the SPLASH program. And this is Chloe Dannon-Felser. She works for American Bird Conservancy and the SPLASH program. And today we're going to be talking about how we as bird conservationists are trying to address the problem of trash pollution. So a little bit of background about the SPLASH program. We were founded in 2020 by 3 partner organizations, American Bird Conservancy, Gulf Coast Bird Observatory, and Black Cat GIS, who you just heard from. We worked together to form a program called SPLASH, which stands for Stopping Plastics and Litter Along Shorelines. Our mission is to create a cleaner environment for people, birds, and other wildlife in the greater Houston-Galveston region. And we do that through education, outreach, community science, and trash removal. Right now, we're going to be focusing on those lower 3, but stay tuned for Liz Virgil, our colleague, who is going to be talking about the education component. So I'm preaching to the choir. We've all heard this many times today, but Texas has a giant trash problem. According to a study conducted by NOAA and the Ocean Conservancy, Texas has the highest weight of trash per mile of any state.
And marine debris accumulates on the Texas coast at a rate 10 times faster than it does on the shorelines of other Gulf states. So we're seeing this problem really heavily affecting our shorelines in particular. So why did we as bird conservationists stick our big noses into this, our big beaks into this? It's because the trash is very detrimental to the birds that we are trying to protect. We see this affecting the birds by obviously dirtying their habitat, but also by physically harming them. We see a lot of entanglement and ingestion. As someone said in their presentation earlier, entanglement is when the animal gets caught up or tangled in an element of trash, and ingestion is when that actually enters their body. So a good example of how we're seeing this affect our birds, we at Gulf Coast Bird Observatory, specifically Dr. Sue Heath, my colleague there, she has been doing a study on the American oyster catchers for, I think it's about 12 years now. It's a very long study. We've got a lot of good data. And of course, her secret motivation is just to hold birds. We all know that. But the American oyster catcher is this very charismatic bird, lives on the shore, and it has a very narrow habitat type. It can only really nest in the oyster shells. So as we see ocean levels rise, that habitat is decreasing. And as that habitat is polluted, it becomes much less usable. So we were seeing a lot of trash entanglements on the Texas City Dike. If any of you are unfamiliar, the Texas City Dike is a very long dike. I think it's maybe 3 or 5 miles long, and it's a very popular fishing site. So it's really unsurprising that we see a lot of birds getting tangled in the fishing line there. For those unfamiliar with entanglement, it might not seem like a big problem to get kind of tangled up in something on your foot. But these birds, they're walking on oyster shells. And so the fishing line will snag on the oyster shells. It will constrict around their legs or their feet. It cuts off blood flow and causes wounds and infection. And these birds oftentimes perish from these wounds. So this is a little bit of data that Sue collected. These are just oyster catchers that she found on the Texas City Dike that were entangled. So it's a very kind of small data set, but you can see because she's been doing it for so many years, we have a lot of data representing how much these birds were getting entangled. And so you can see that line there, 2020 September. That is the date when we did our first cleanup on the Texas City Dike, and it's the last date that an oyster catcher has been entangled on the Texas City Dike. So that's really encouraging for us, letting us know that we're picking up the correct trash and helping these animals. And of course, it's not just the oyster catchers that were benefiting from this. We have lots and lots of birds that use the Texas coast as their habitat. Snowy plovers, Wilson's plovers, least terns, and black skimmers are all birds that can use some help. They've seen population declines in the past 50 years, and they will likely benefit from all this trash cleanup. So that's why we're involved in this kind of trash world, and Chloe's going to tell you how we're trying to address this problem.
Thank you, Celeste. All right, wait, is this working? Okay, cool. So like we said earlier, Splash has only been around since 2020. And since then, we have picked up over 30,000 pounds of trash and directly engaged with over 10,000 people through our cleanup events, educational programming, and just volunteers and outreach events. And we have had over 184 events to meet all these awesome people. So those are big numbers for only, a few years. So I'm very excited about that. We couldn't do it alone. We have an awesome network of volunteers. We have had over 1,600 volunteers that have committed over 4,000 hours at our cleanups, and they're really fun cleanups. So you guys should totally come out. They're really fun. We have a lot of repeat volunteers that are very passionate about the habitat and the birds. And so it's always a good time. So cleanup sites, how do we pick them? We try to pick sites that are either super, super trashy, or very important for bird habitats, but often those are both. So you can see here on our map that's also on our website, some of the locations we've done in the past over there. So you can see we've gone into the Houston bayous and the Galveston beaches and the bays. So yeah, pretty cool. An example site is Monument Inn In 2021, it was just covered in litter. It was totally unusable. It was just drowning in trash. As you can see from this picture, it was totally awful. Here's another picture of what it used to look like. And after 3 splash cleanups, it has really already improved. And here we keep track of all of our, the trash we pick up at these cleanup events. And Monument Inn is #1. We have picked up over 7,000 pounds from that location. And now it's really crazy because people are actually using it. At the last cleanup we were at, there were some fishermen, there was a Nurdle Patrol group, and there wasn't as much trash. So it's really cool to see how our cleanups are making areas usable for more citizens. So whenever we do a cleanup, we almost always do a transect where we measure out 100 feet and we clean up all the trash in that area. And then once we picked up that trash, we go and sort it in a way that is very similar to the STOP method. So we lay it all out, we sort it, and then we put it in the Texas Litter database. And it's very interesting because we like to compare our data to what is being found nationally. So like at our cleanups, we have found that styrofoam fragments are the #1 most popular item, while according to the Ocean Conservancy, cigarette butts are the most popular item at their cleanups. We also have a lot of hard plastic fragments, plastic film fragments, and bottle containers and cans. And our hopes is that one day we can use this information to go to local municipalities, businesses, and help them create trash management plans so we can help decrease this litter that is being found in our waterways. So like I said, we do trash management plans. An example of this is at the Crab Street wetlands in Surfside. It is a birding hotspot. Over 190 species have been sighted there, and it is also a fishing hotspot. So there's a lot of derelict fishing gear, such as fishing line, traps, all kinds of stuff like that. And the birds were becoming entangled and eating it, and it was a whole mess. So we partnered up with some other organizations to create a trash management plan. And that means organizing cleanups. That means installing more beach signs that spread awareness about litter and not to do it. And also installing trash cans and more fishing line disposal bins. We have this really cool project going on where kids can make their own beach sign art. So you can see here some of the cool artwork we've got in, and that is being installed over at the Crab Street wetlands. Another really cool success story is Nest Fest. Nest Fest was our first large-scale cleanup event. We partnered with the Gulf Center for Sea Turtle Research, the Galveston Bay Chapter Texas Master Naturalists, and Surfside Beach Tourism to put this on. It was an awesome event. We had 12 locations on one day, and the goal was to clean all these beaches for beach nesting birds and sea turtles. And we had over 300 volunteers, and they picked up like over 2,300 pounds of trash. It was an amazing event and a total success. We hope it can happen next year. Y'all should all come out. It's going to be great. Yeah. So what's next for Splash? We want to do more cleanup events. We want to reach more students, and we want to have more partnerships. We love working with partners like conservation groups, local governments, businesses, clubs, and fishermen. We need to get the word out to them to, put away their fishing line properly, and we would love to cover more area. Here's some fun pictures from our events from Kingwood High School, the Hummingbird Extravaganza, and another cleanup. And yeah, so yeah, y'all should totally join us for a cleanup. They're super fun. We have at least one public cleanup per month. We have 2 this month that are going to be super fun. And we can also do private cleanups. So if you have a school group, a club, an organization that needs a service project, come find us afterward, and we would love to set that up for you. We can really tailor it to whatever your club wants. So time, location, all kinds of stuff. So yeah, thank you guys for listening to our chat.
Thank you both. Any questions? No questions? Got one right over here.
Okay.
We find many balloons, and I highlighted the fishing line as an entanglement problem, but balloon strings are an entanglement problem as well. And so one of our biologists, she does surveys on the Matagorda beaches, and she actually will count every single balloon that she sees on the beach Sometimes, particularly after holidays, like Valentine's Day, I think is the worst. She'll pick up like 400 balloons in one day. So it's a huge problem. Yes.
Amanda, did you have a question?
I forgot to mention, whenever we sort the trash, we always put it into the Texas Litter Database, which Amanda is aware of. And we have a really cool story map, there we go, that she and her awesome team have set up for us. So our website has it. It's so cool. It's amazing. It's very interactive. So you can see all of our locations, how much trash we picked up from it. And it's very, very cool. Highly, highly recommend it. It's all on our website. So if you want to scan that QR code, you can check out that super cool story map.
Okay, thank you. Okay. It's time for a break. We're a little bit behind, but we are still going to take about a 15-minute break till 3:15. For those who are judging, make sure you give your judge sheets to Lisa Scoble so that they can start tallying those up. So be back at 3:15. Thank you, everyone.
All right, for the sake of time, we're probably just going to go ahead and get started and people can trickle in as we go along. So our first presenter in this solutions category, we're on the home stretch now, last session, is Kasia Dinkaloo, and she's going to be presenting on bioprospecting plastic pollution solutions.
All right, thank you so much for having me, and hopefully everyone is on the up and up after a little sugar, caffeine, and movement. So today I'm going to be talking about bioprospecting for plastic pollution solutions. And I'd like to start by advancing my slides, which all right, so I'll start by thanking our funding and research support sources. So both monetary and emotional research support. I'm a part of the College of Natural Sciences at the University of Texas at Austin. And within CNS, I'm a part of a program called the Freshman Research Initiative. We get monetary support from the Stengelwire Endowment and HEB, and we get research support from the Nurdle Patrol and the Brackenridge Field Laboratory. So, too far. I wanted to introduce my research group. I am what's called a research educator at UT Austin, and with the help of Dr. Andrew Ellington and Dr. Jennifer Broadbelt, I run a lab of approximately 45 undergraduate researchers. So I have a lot of students as partners to do research. So the Freshman Research Initiative at UT Austin is a unique program aimed at involving college undergraduates with research kind of as soon as they step onto campus as freshmen. There are 35 different streams, which are research labs pursuing novel topics in STEM. And freshmen join their stream or lab in the spring of their freshman semester, spring. And they can elect to stay involved with the research kind of throughout their college career. So the typical research timeline for FRI students is in the fall of their freshman year, they'll take a research methods course. In the spring, they will join their research lab where they're trained on basic either wet lab or dry lab skills, depending on the topic that their lab studies. And they can return for more basic bio or chem lab credits in the fall with an option to be funded during the summer to start their research. In the fall, they start independent projects, and then in the spring of their sophomore year and beyond, they can stay associated with the labs as peer mentors or as independent researchers. And this program has been around for about 10 years. It's the largest undergraduate research program in the nation, so we're very proud of that. And it's been shown to increase retention and graduation rate of STEM students and give them a really strong sense of belonging within the university, as well as allowing them to learn foundational concepts while they're working on kind of these real world problems. So my lab focuses on bioprospecting, and bioprospecting in its broadest term is just the search for useful products from nature. And these can be medicines, materials, enzymes, really anything that we can use that nature already made in a very good way. So our bioprospecting stream focuses on plastic pollution and plastic degradation as central themes for both education and research. My students are currently working on several different areas to do with plastic pollution degradation. So today I'm going to try and briefly overview the work they're doing on plastics and the rhizosphere, bioprospecting for plastic degrading microbes or enzymes from nurdles, and bioprospecting for plastic degrading microbes or enzymes from the gut of plastic-eating beetle larvae. So our big push and our big useful product that we're searching for are enzymes that are capable of depolymerizing different types of plastic polymers. I'll start talking about a project called Impact of Plastics on Rhizosphere Interactions. And the aim of this project is to study how microplastics may influence or interrupt interactions between plant roots and the microbes that surround them in the rhizosphere, which is the area of soil that's most closely associated with plant roots. And in this project, we have a lot of questions, but mostly we're hoping to create methods that will allow us to quantify microplastics in the soil. And I don't think we've seen any talks on this topic. There's been some about microplastics and sediment. It's very difficult to get microplastics out of the soil matrix. And since we're also interested in characterizing and working with the microbes that might be associated with both these plastics and the plant roots, it adds another layer of challenges to our project. But our hope is to kind of understand how the occurrence of plastics in soil might influence or change the way plants and microbes interact in these highly diverse and concentrated, like microbial cities within the soil. And the status of this project is that we definitely have more questions than answers. So I encourage you after this to go look at Wendy's poster, because he's done a lot of great work on different plastic staining techniques so that we can visualize plastics in the soil. We've sent students out to do a lot of sample collection, but we are definitely moving slowly because it is a big challenge to figure out how to work with both plastics and plant roots in this soil matrix. The next topic I want to touch on is my group that have named themselves the Nerdlers. I don't have to introduce Nerdles here, which is fantastic, but the aim of this project is to look at, collect and study microbes that are found on the surface of Nerdles. So, so far, our Nerdlers have had the terrible misfortune of having to go to the beach from Austin to collect samples. Jace and Dr. Liu have been really helpful in this, so we'll go down to Port Aransas. We've been able to visit Dr. Liu's lab to use his equipment to identify the polymer composition of the Nerdles that we've collected. And then we bring those Nerdles back up to Austin so that students can work with them to isolate and identify the microbes that might be found on the surface of these Nerdles. And what we are doing is, firstly, we're trying to create what we're calling a Nerdle-associated microbe, or NOM, library, in which we isolate and culture microbes from Nerdles. We use DNA barcoding to identify the species, and then we store them in a glycerol stock library so that we have them available for future studies. And what we found so far is that there are many, many species of Bacillus and Lysine species that have been isolated, which is really interesting. Especially because when we started this project, we were using Nerdles sent to us from the Nerdle Patrol. So they had been sitting in these glass vials for kind of an unknown amount of time. And these species of bacteria are known to have really long-lasting endospores that can kind of persist on difficult surfaces. So our hope is that some of these microbes might hold enzymes that use those Nerdles as a carbon source and can therefore degrade the plastic. The other project that we're working on with the Nerdles is the Nerdleome. And this is born out of the fact that although microbes are surely on the surface of everything, not all microbes can be cultured in the lab environment. So we are working to isolate microbial DNA directly from the Nerdles without culturing anything first, and using that for metagenomic sequencing. And what we found so far is that it's really hard to extract DNA from plastic. So getting a high enough yield for amplification has been difficult, but now that we have done that, when we amplify that DNA with universal primers, we are seeing both prokaryotic and eukaryotic species on the surface of these nurdles, and we'll be using that for metagenomic sequencing. And it's kind of nice to see, even though we use bulk samples, so maybe 50 nurdles at a time, we've got great nurdle diversity, weathering, different colors, plastic types. I'm never not appreciating the beauty of nurdles. The last thing I want to touch on are our superworms. So hopefully all of you visited the posters and got to see our little terrarium. Superworms are the larvae of the darkling beetle, and they eat polystyrene without adverse effect. So it doesn't kill them, it doesn't cause them to pupate early, and it's really wild to see and relaxing to hear. It sounds like the ocean. So we've been studying these worms, and we're hoping to look at the microbes within their gut that have been shown to depolymerize polystyrene. We feed them a diet of styrofoam and other items, and after several weeks of altered diets, we can harvest their guts for anaerobic cultures, for direct DNA extraction and sequencing, or we have been isolating them to encourage pupation. They turn into beetles, the beetles mate, and then we get to study the next generation of worms. So we're kind of looking at how the gut microbiome shifts after generations of plastic exposure. So far, we've been working on this project consistently for about a year, which is good because our anaerobic cultures took 5 months to grow. So we cultured the guts in media that did not have a carbon source except for polystyrene in an environment without air, which mimics the gut of the superworm. And what we saw right off the bat is that when we spin down the cultures, we have a really nice bacterial pellet coming from cultures started of worms that ate styrofoam, and kind of like a weird, wimpy black pellet from the worms that were not previously fed styrofoam. We popped that under a microscope. We were able to see what I'm assuming is bacteria in our experimental flasks. And when we used DNA barcoding, we saw that a lot of the cultures contained Citrobacter species. So now the race is on to try and isolate Citrobacter so we can study it further in our lab. And then much like the nurdles, that which we cannot isolate and culture, we should just study directly by direct DNA sequencing. And when we use our universal primer sets, we do see that not only is lots of bacteria present in the superworm guts, but also potentially fungi or other eukaryotes. So I'm excited to see where that sequencing leads us. And the last thing I want to touch on is that we are starting a program with local high schools where we are bringing the worms to the students and using plastic degradation and pollution as a theme for conversations about biotech, experimental design, and sequencing. So we give the students worm kits. We give them free range to feed the worms as they say fit. So we've been doing memory foam, bubble wrap, 3D printer waste, kind of everything. We'll collect the frass, which is the worm poop, and then sequence that and visit the high school again to talk about our results. So to wrap things up, my lab is a large group of undergraduate researchers who are working to find useful products from nature. And right now we are focusing on searching for enzymes that can degrade plastic polymers. And as always, we're looking for collaborators and hoping to work with you because you're all collecting so many cool plastic sources and we want to analyze their microbes. So thank you so much.
Thank you. Any questions for Kasia? George.
Yes, so previous studies have been published and a fair amount of work has been done on several different beetle and moth larvae species that will eat the styrofoam. And I think it started as a lot of these are reptile food. So if they happen to try and ship them in a styrofoam cup or something, the worms would chew through it and people realized that they weren't dying while eating straight plastic.
The question was, what made her decide to use those worms? Any more questions? Up top.
Yes,
Question was
so the-
large scale consumption.
Yes. So there is interest in making large scale kind of worm composters, which is feasible, but a better target for industrial scale would be the actual enzyme that's depolymerizing the plastic.
All right, maybe one more.
Have I
Cigarette
fed any
butts.
what?
Cigarette butts.
I have not. I will take some butts. Yeah.
All right, thank you so much, Keisha. That was
Thank you.
fantastic. Next up, we have Liz Virgil presenting on environmental education and effective litter prevention strategy.
Yeah, thank you. I love that. Thank you so much. So yeah, my name is Liz Virgil, and I'm the education specialist with American Bird Conservancy. So you learned a lot about Splash from Chloe and Celeste and our outreach efforts and our cleanup efforts. And I'm here to talk about our education efforts and how we found it to be a pretty effective strategy when talking about litter removal, but also litter prevention. So I'm just going to skip that because we already learned about it. So our target audience with environmental education is oftentimes youth and students K through 12 grades, which is 5 years old to 18 years old. Sometimes we even do pre-K younger. And so that, you might think that that's not really an impactful audience because they aren't necessarily making decisions at home. But it is anything but that. We are educating future environmental stewards. We are talking to them about a very real world environmental issue and also introducing them to skills. So developing them to be future mitigation strategists so that when they do become voters and start to have their own money, make their own decisions, they can make them hopefully more sustainably. And furthermore, we're also speaking to intergenerational learning here. So when kids get excited about things that they do in school or go on beach cleanups, field trips, when we come and we guest speak, they oftentimes go home and tell their family, or they get inspired to ask their family to change their own behaviors. So we have direct numbers on the students that we reach, but the students have the potential to reach so many more people. And I think, Dickinson High School is a great example. They came out here. We did a cleanup with them where we collected that 2,700 pounds of trash. And then they came to you guys and talked about it and talked about the impacts of marine debris. So it's really cool how we can reach through environmental education, whole communities. So just that alone, I think is why, education in general is so important. But we have I'll talk about our stats first. So we've reached, including Dickinson High School, 43 schools in the Houston-Galveston region, over 4,000 students, and we've collected data through surveys to try kind of keep track of feedback, but also the impacts of our education efforts. But the 3 strategies before I go over that data that we consider when we make our curriculum are as follows. So first, we want to make sure that our education supports educators. So all of our curriculum, all of our lessons, all of our activities are state standard aligned so that teachers can get support from their administration, also make sure that they are checking off, the boxes and the requirements for their own curriculum throughout the year. We also have all supplies that are needed to run our cleanups and to do our programming. So that speaks to the accessibility of our lessons, of our curriculum. And so there's really no cost to the school, especially if we come to their campus, which is really awesome. And then we also have differentiated lessons, differentiated activities, so that teachers can modify based on the students' needs. And it's also grade appropriate. So what 4th graders are learning and what 12th graders are learning is a similar concept, but in different ways that's age appropriate. We also make sure that our curriculum is student-centered. So we are not up here lecturing like how I am today. This is kind of a very different environment for me. Usually we are doing experiments or doing modeling, or kids are doing hands-on activities where they're building watersheds or sorting trash, or they're out on the beaches and the bayous with us and actually collecting data so that they can make their own conclusions about the trash problem here in Texas. We have something called a flipped classroom where we are essentially doing that. We are giving them a question, and through our activities, they're able to answer that and come to their own conclusions themselves. And we've also started to incorporate some like perspectives takings, like through town hall meetings. We also have them do help with our community science efforts. So they're directly helping us to put data into that Texas Litter database and into our own story map. So they're also helping our program as a whole, which is super cool. And then partnerships is probably like the biggest strategy that we found to be successful in our environmental education efforts, because collaboration is absolutely key. We are able to make deeper impacts by partnering with people like the Houston Botanic Garden, the Houston Zoo. We have partnered with Jesse Jones Nature Park. So places that actually have a facility where students can go and they can learn about a local habitat. And so they grow an appreciation for that nature. And then we come in and we talk about this very real environmental issue. And so they feel more motivated to do something about it. It's very experiential. So we've gone to, like I said, Jesse Jones. We've worked with even like SELF and gone to Westbury High School. Here are a bunch of other partners in schools. Like I said, Dickinson High School is one. And it's all over the Houston-Galveston region. So it's pretty cool, you know, how we're continuing to build in our partnerships. So with these three strategies, we have kind of cast a wide net of the curriculum and the lessons that we give. But before they do our curriculum and go through our lessons, we have them collect surveys and data about kind of trash and their opinions about plastic. And so before our lessons, we found that students, after they took our survey, not really a lot of them felt obligated to avoid single-use plastics. Over 40% never, to sometimes avoided things like plastic straws, water bottles, grocery bags. But directly after our lessons, we found that it was totally flipped, where over 50% felt very motivated, extremely likely to avoid those in the future. So more specifically, they not only felt motivated to reduce their single-use items, but also to encourage others, which is speaking to that intergenerational learning, that community awareness, and spreading the word, which is the ultimate goal of what we're trying to do with education. So this is the wide variety of things that the tools that we offer, anywhere from staff-led lessons where we can go to classrooms to teach about marine debris. We also do on-campus cleanups for especially schools that aren't able to go on our field trips. Our field trips include going to bays and bayous, doing transect surveys, talking about marine debris, and then also encourage them to do something with that data. Once again, like how Dickinson High School came here and shared, which is super awesome. Like that really blew me away. That was so cool to see that. That was very organic, unplanned. But we also have an educator's guide and a free supply kit. So educators don't have to rely on us coming to their classroom, but they can lead the lessons on their own. Which is super awesome because in case we're busy or whatever, we're able to reach a lot more people, a lot more students. And then we also have a lot of online marine debris courses, activity books, and also a beach art sign challenge. So Chloe talks about it a little bit, but this is where we are using education to directly impact communities. So we're working with Galveston Island Park Board, Surfside Tourism, Quintana Beach County Park, and we are going to post student artwork at high traffic beach access points. So we worked with a couple of schools, but also the Houston Botanic Garden Spring Camp. That's what these pictures show. And so students learn about marine debris and then actually do something about it. So we've had over, I want to say, 100 submissions so far. Where we're getting like really cool pieces of art. And so we're going to choose out of the 100 a sample to print out and actually post. So kids will be able to go see their own efforts and their own work and how it's been impactful, and hopefully we can reach, hundreds more people who are visiting the beaches, especially like right before tourist season. So really excited about that. But overall, we would love to continue to develop partnerships, whether that's educationally or you're interested in doing a cleanup with us. We'd love to collaborate. Education is definitely like one of the most important solutions and steps to creating long-term problems, because no one can do anything about it until they learn about it, right? So if you're interested, here is my information, and that QR code leads you to our educational site so you can get more information. So thank you very much, and I'd love to hear questions.
Any questions? One. All right, go ahead.
Yeah, so we're in the region 4 like area, which is like Houston, Galveston. So far the most north we've gone is Kingwood, but we are like we've talked about before, trying to expand. So I would say if you're like within like a 2-hour range of like Houston City, it's a possibility. But yeah, if you're interested, I'd love to talk to you further about that. Yeah, that is yeah, I should. I will.
That question was how she reached out to the Children's Museum.
Oh, right on. Okay. Okay, cool. Yeah, that's a very good idea.
Any other questions? All right, thank you, Liz.
Thank you.
All right, next up, Surfrider Foundation's local and national efforts to reduce plastic pollution. We have both Neil McQueen and Jennifer Savage.
Good afternoon. You guys are the diehards. You stuck out this long, so thanks for being here. So I'm really thrilled to have Jennifer here. I'm in Texas in Surfrider Foundation. Jennifer is the senior manager for the Surfriders Plastic Pollution Initiative on a national level. So it's really cool. If you haven't heard about the Surfrider Foundation, we are a national organization. We do have international affiliates as well. I'm with the Texas Coastal Bend chapter. We're not all surfers, we're beach lovers. We concentrate mainly on clean water, clean beaches, and public beach access. These are all photos from the Corpus Christi area. One of the things that we do is really great is we have a disabled surf camp every summer, which is really fun. We do beach cleanups, obviously, and just really try to take care of our beaches. And back in 2010, I helped to start the local version of the national program's Rise Above Plastics. We call it Skip the Plastic in Corpus Christi. And the reason being is that we've seen a huge amount of plastic in beach cleanups nationwide. Those are all photos from the Coastal Bend, unfortunately. That photo of the bag up on the upper right there, I call that the city flag of Corpus Christi. Corpus Christi is a really windy place if you haven't been there lately. The average wind speed is probably 15 miles an hour daily. And so one of the things we do now is we have cleanup heroes. So every month we'll feature different heroes, and we put out a press release to the local media, and they get featured. And what we're trying to do is just trying to create a culture where we're cleaning up your local beach or park or shoreline, wherever you are, it should be encouraged. And this photo here on the upper left, that was on last Saturday. That's along the shoreline of Corpus Christi Bay in my neighborhood. And there's a stormwater outfall that empties into the bay right there, pretty big one. So these are all students except for me, I'm the old guy. But these are all Texas A&M students. And in just a couple hours, we picked up 273 pounds of trash. This is kind of a before photo and an after photo. Out of that 273 pounds, 45 pounds was styrofoam, and styrofoam's light. So think about that. And 80 pounds was plastic bottles. So it's a pretty significant problem, but it's gaining some traction. We're getting, some good PR out of it, and people are getting the message. Cleanups are good. Another project we're working on with the city of Corpus Christi. This is a pilot project. They're going to try trash interceptor devices at 8 different outfalls along the bayfront. This is actually downtown Corpus Christi in the city marina right there. So they've invested $1.7 million, and we hope to be doing the ribbon cutting on that very soon. And then they'll determine which ones of those devices work best. And then we're going to help them prioritize, hopefully, where future ones should go around the bay. In the city of Corpus Christi, we have 84 stormwater outfalls that go out into our water bodies, not on the Gulf beaches, just in the bays. So you guys, nurdles, here we are again, talking about nurdles. The nurdle bill, I don't see Jace here right now, but because of the Formosa plastic settlement, we started talking and said, if Formosa, one of the most highly polluting plastics facilities in the state can clean up their act, maybe everybody else can. So we started working on the nurdle bill, and it's been reintroduced this session. Representative Zwiener out of San Marcos filed it in the House. And then I've been working with them as well on a couple other bills, or hope to be working with them some more. One is HB 2050. Y'all saw Maya's slide, which was really comprehensive on a bunch of bills related to plastics. But HB 2050 wasn't on there. And that bill, if passed, would allow cities in Texas to start banning plastic bags and single-use plastics again. You might recall that the city of Laredo was challenged in the Texas Supreme Court, and the Texas Supreme Court declared their bag ban to be illegal. And then that was followed up. The state attorney general sent threatening letters to all the other 10 cities in Texas that had plastic bag bans that they needed to cease and desist, or the state was going to come after them. So they all dropped them. So this bill would change the language in the Texas Health and Safety Code so they could reestablish plastic bag bans. Kind of related to an earlier talk, but more in the coastal bend, we have a lot of industrial growth in the Corpus Christi area. There's a lot of oil gas, 5 new pipelines coming into the Corpus Christi area from the Permian Basin and the Eagle Ford Shale. And so basically industry is tripping over themselves to either use that oil and gas for petrochemical production or to export it. And so many groups were very concerned about this industrial growth. I'll show you a map on the next slide. But we created this organization called CAPE. It's the Coastal Alliance to Protect the Environment. There are 23 organizations in this coalition, very diverse. And that's, try to keep 23 organizations moving together in one direction. That's a pretty good feat. This guy here, that's Errol Summerlin. He's a retired attorney. And he's kind of the figurehead of the organization. I encourage you to check out the website, capetx.com. It's kind of common problems that y'all have here in the Houston area. By the way, I grew up in Houston, so I'm very familiar with this area. And so CAPE, this is the north, so this is Corpus Christi down here, and we've always had 6 refineries up the inner harbor here, but now we've got this massive growth along the north side of the bay, which is the undeveloped part of the bay. And the cumulative impacts of air pollution, water pollution are really significant if all this goes through. Another thing is these industries require tons and tons of water. Another name here that was brought up earlier, this is ExxonMobil, SABIC. So that is currently the world's largest factory for #1 plastic, PET. And they require 20 to 24 million gallons of water a day. So they want to build all these different desalination plants that are being proposed inside the bay. Up to 5 of them that would take the water out of Corpus Christi Bay, which is fairly enclosed, and discharge the brine into the bay. And so that's a big part of the battle. And I think with that, I'm going to hand it over to Jennifer.
Thank you. And it's so exciting to be here. I haven't been to Houston before, so I'm learning so much today about Houston itself, but also the larger problems that Texas is facing that are unique to Texas and some that are universal. And so I thought I would talk about Surfrider's way that we achieve solutions to the plastic pollution crisis. So just a little bit about Surfrider to start off is, as Neil mentioned, we are a national organization. We have international affiliates. So we have currently 76 chapters, largely volunteers like Neil and Rob is here, around the country, everywhere from up in Maine to throughout California, the Pacific Northwest, down in Florida, out in Hawaii, many chapters here in Texas, all all throughout the coastal United States. And we also have more than 140 college and high school clubs at this point. So we really have a growing, powerful movement among the younger generation, which of course is really key. We've heard some great speakers here today just in talking about that. And then we have 5 international affiliates. So I'm Jennifer Savage, and I manage our plastic pollution initiative with this great team of people. Oops. All right, so the way that Surfrider approaches achieving this goal to end plastic pollution is through 3 different paths, right? First, we work on policy. We work on policy at the local, state, and federal levels. So everything from hardcore grassroots activism to large-scale national expertise. We also have 2 different programs within our initiative. One is our Healthy Beaches program, which is primarily focused around our beach cleanup activities. And then we have our Ocean Friendly program, which started off as our Ocean Friendly Restaurants program, but has now been growing to encompass even more businesses. So I'll talk a little bit about these both in depth, but just to give you an idea of the Ocean Friendly program, what we do is we really support businesses adopting plastic-free and sustainable practices, and we offer them all kinds of support to achieve that goal. So our current priorities are based around source reduction, refill and reuse, and environmental justice. So source reduction, we really see as, clearly preaching to the choir here, as the key to reducing plastic pollution. If we want to stop plastic pollution, we have to stop unnecessary single-use plastic production. And we are in the policy work that we do and in our ocean friendly programs work that we do, we're really pushing for a change from single-use products to refill and reuse as the way to go. So we're more interested in refill and reuse than trying to substitute products in the big picture. And then environmental justice, of course, is a really core component of the plastic problems from start to end, as has been covered very well today. So I won't spend too much more time on that, but I just wanted to echo the concerns that have been brought forth. So we also engage with our coalition partners on a number of potential issues, many of which again have been so many of the presentations. I'm like, oh, great, they're already talking about this. So, talking about problematic materials. So there's a lot of greenwashing that's being done in the realm of, bioplastics. And we see a lot of, so-called compostable materials, but in places where there's no actual industrial composting facilities, or maybe they are not actually compostable anyway. And it's really confusing for business owners and for individuals who are trying to do the right thing. So that's a huge part of our work right now, because there's so many false solutions that are being put forward. Also, looking at oil and gas setbacks and how that applies to like chemical recycling and plastic production facilities. Looking at, issues around microfibers, that's becoming more and more a concern that I think the general population is becoming aware of. I mean, I live in California, so that is something that's come up in our state legislature multiple times, trying to get bills passed to deal with microfibers. Also, looking at the plastic burning, as was articulated so well earlier today. And so our goal at Surfrider, the big picture, is we want to eliminate all single-use plastic pollution in the United States by 2035. It's a pretty ambitious goal, but we're working toward it, and we believe in setting high goals. We have a pretty good track record. We've been around since 1984 and have hundreds and hundreds and hundreds of political victories at this point. So we do have a good foundation on which to build optimism for achieving these goals that we have set. And so, we're working at the local level and the state level. We've had a lot of success across the country. And the next big step, of course, is trying to get something done federally. The political climate clearly is not so much in our favor right now, but there have been a number of really important bills that were introduced in the past couple of years. The biggest one being the Break Free from Plastic Pollution Act. And that's this huge comprehensive bill that just really covers like everything you could want if you're trying to end plastic pollution and address the production issues, address environmental justice. And will that pass? No, but I mean, I hate to say just a blanket no, but it's highly unlikely. But what we are also working on is a number of bills that are being pulled out of Break Free, so that have a better chance of getting perhaps some bipartisan support and potentially moving forward. And in the meantime, the fact that these bills are coming up, that we have legislative champions in Congress, it's helping to build momentum and further the conversation and really continue to inspire people to keep working on this problem. We are also, I didn't put this on the slide, but we're also engaged on the Global Plastic Treaty. So I'm very excited that I get to go to Paris at the end of May to participate in the International Negotiating Committee meetings. And we're working with our international affiliates to try to get to a good place with the treaty and make sure that the US is doing a lot better than it is at the moment. All right, so our beach cleanup program is really the way that most of our volunteers come to Surfrider. They see trash on the beach, they don't like it, they want to help clean it up. Then they are asking like, why is that all this trash here in the first place? And next thing you know, they're going to city council meetings, they're going to the state legislature, and they get really involved in the policy front. It's also a fantastic way to collect data, as you all know, because so many of you talked about the importance of gathering data, and that helps to drive policy change. And then our Ocean Friendly program, as I mentioned, is really about supporting businesses who want to do better. And it's so critical when you're talking to elected officials to have business voices in the mix and to show that it can be a really positive economic driver. And so we have, I think we're up to over 300 ocean friendly restaurants at this point. Yeah, 331 active restaurants at this point. And it represents, over 60,000 plastic-free meals throughout the United States every day. So it really has a huge impact, and it's growing all the time. We're looking at expanding into other industries, particularly in the hospitality area, such as such as hotels and ocean-friendly events. And there's just kind of endless opportunities. So that's a big part of what we're doing. And with that, I'll wrap up. So thank you.
Any questions for Neil or Jennifer? Lower one over here. The question was about the trash traps and wanting more information on those.
And I think it was also if we adopt them,
Yeah.
was that correct? Not officially, no. I've kind of adopted this one because it's in my neighborhood. I've actually been going up into the watershed, if you will. And again, because it's in my neighborhood, I've been bugging the city about this particular area for quite some time. But that would be a great idea to have organizations adopt a specific outfall or a specific area. One of the things I didn't show on that slide, let me if I can get back to it, about the pilot project. And again, Jace is not here and I can't get any farther back than that. But there's a video on Facebook or on YouTube, I'm sorry, it's called All the Cups. Has anybody seen that? If not, you should check it out and so that one video raised a lot of eyebrows in the coastal bend. And that's about one specific storm drain outfall that goes into a major park in Corpus Christi. And it was such a big deal that the city featured it on that poster about that pilot project. But I like that idea about particular groups adopting outfalls. That would be a great idea. And there needs to be much more awareness, I think, especially in our area about outfalls. It's people don't really, it's kind of a mystery. How does this stuff end up here? And it's really pretty obvious if you start looking at it.
All right, I think we had one more question over there somewhere. Okay, go ahead.
Okay, I'm sorry, I couldn't hear your question. Maybe, can you?
I think she had asked if there was an effort in Houston to stop the plastic recycling. Is that what you had said?
Or the
Or the
desal?
Can you speak a little louder,
the
please?
chemical recycling. Were there efforts by Surfrider?
Oh, with efforts to stop the chemical recycling by Surfrider, is that correct? Jennifer might be able to speak to that nationally.
Yeah, I'm sorry. I heard you say that something about the desal plant in Huntington Beach. Sure. Okay. Well, so this was a huge victory that happened in Southern California, where a massive desalination plant was proposed for the Huntington Beach area, and it would have been really deadly to marine life. This ridiculous amount of greenhouse gas emissions. It had a lot of political support. The governor, Gavin Newsom, was this huge booster for it. It was a incredibly hard fought and frankly unexpected victory. I don't want to spend too much time on it because we're here for Texas, but it to answer the question, that was like 20 years of battling that plant, from the most hardcore grassroots partnerships, partnering with our EJ friends, partnering with labor unions, and then, working on the science aspects, working on sea level rise aspect, bringing every possible tool to the table and fighting tooth and nail, and having, we had the right decision makers in place. The California Coastal Commission had the final authority on whether or not that would be permitted. And it was, years of attending those meetings, building relationships, and, every political tool in the toolkit it took to stop that. But it was, like, I was at that meeting, and I've been to a million meetings at this point where decisions are being made. I've never been to a meeting that was so hardcore, so profound, and had such an unexpected victory. It was really, truly remarkable. And it speaks to the power of doing the work and showing up, even when it takes forever and you get super sick of it, but showing up and making those decision makers look you in the face while they're taking their vote. It can make a super powerful difference. And it did. Whatever the issue is, showing up is never not a good idea.
If I could add one little thing, if you want to read closer to home in Texas, if you want to read about challenges to desalination, check out that website, capetx.com. CAPE is fighting all 5 desalination plants currently. CAPE is challenging 14 or 15 environmental permits at this moment. Thank you.
Awesome work, guys. All right. Next up, we have city scale reusable foodware systems by Christina Gherkin.
Good afternoon. I'm Christina Gherkin, and I'm here with Perpetual. And we believe reuse is for everyone, and we are working to bring city scale reuse to 4 smaller cities in the US. So why reuse? A 2020 report called Breaking the Plastic Wave from the Pew Charitable Trust found that reuse is the biggest lever towards reducing plastic waste and pollution. And reuse just makes more sense than using things for a minute and then throwing them away. Now, when we look at reuse, we look at 2 types of reusable foodware systems: open loop systems and closed loop systems. Closed loop systems are in cafeterias, in, say, music venues or arenas. It's where items never leave the system. And we think that these sorts of systems can be solved by a single player. Like we have our cup and Redish. And then we have open loop reuse systems, and this is where items circulate throughout a city. So how open loop reusable foodware systems work? You'd go to your favorite coffee shop in the morning. Instead of getting an item in a disposable coffee cup, you get it in a reusable coffee cup. You could take your coffee to the park or to your office, and when you were done, you could drop it in a convenient bin that's located all around town. Or if you were meeting a friend for lunch, you could bring the coffee cup with you and drop it in the bin at the coffee shop. Then once those bins are full, someone will come and empty the bin and take the items to a centralized washing facilities where the items are washed, sanitized, inspected, and then redistributed back to the restaurants. Now, for the restaurants and other local businesses, they would get these reusable items as either reused per wash or as a monthly service that is comparable to what they're paying for single-use disposable items. Over the next couple of slides, I'll show you some examples of some reuse systems that are currently operating. There is Recup and Rebowl, and that is operating in Germany, and they're actually the local partner with Burger King for reuse there, and they are available at over 20,000 locations throughout the country. Then we have the Tim Hortons, Sharewares, and City of Vancouver partnership. If you don't know Tim Hortons, it's like the Dunkin' Donuts of Canada. And they actually have 60 return bins throughout the city where you can return your reusable cups. And we have a partnership between Our Cup and the City of Seattle, where Our Cup is bringing reusable cups to music venues throughout the city. So it just makes sense. Instead of getting a beverage in a disposable cup, you'd get it in a reusable cup. Deliver Zero is operating in New York City. So as you get food delivered to your house, instead of getting it in a disposable container that you have to feel guilty about, or maybe send other people home with food from your house in those containers, instead you'd have the items in a reusable container. And then when the item is empty, you could either bring it to return bin, or next time you're getting delivery, you could just give it to the delivery person. And my last example is Bold Reuse. They are operating in a number of cities in the US. They've actually been around for quite a while in Portland, Oregon, and they've launched their newest system in Bentonville, Arkansas, which is the home of Walmart. So challenges for open loop reuse systems. It's difficult to get to convenience and affordability with pilot programs. If you have something that's operating in 10 coffee shops or businesses, that means consumers have to go out and actually find the reuse system, and then they have an item that they need to figure out where to return. And then for businesses, it can be difficult because they have to explain to every customer how the system works. It's also hard to get to the environmental benefits of reuse when we're not operating at scale. And lastly, we don't have good established governance models for reuse. And governance models are important because we want to make sure that these systems are equitable and accessible for everyone. So really, immersive scale is the key. When reuse systems are operating at immersive scale, it means that we're achieving both the environmental and the economic benefits of reuse. The cost per wash can be much less when the system is operating at scale. So Perpetual set out to look for smaller US cities to operate a reusable system in. We were looking for cities of about 50,000 to 150,000 people. So small enough that we could talk to every business, but big enough that other cities could kind of see themselves in that city. We needed population density and really like a geographically contained area so that it wasn't like a suburb of a big major city where people lived in the suburb, but they went to the big city every day for work. And we really wanted a diverse city. We wanted a city where everyone could see themselves in, and diverse politically as well, so that it wasn't like reuse was from one group or the other. We didn't want reuse to be polarizing. And we thought that cities near waterways where people could actually see the trash that's accumulating in the water would make the city very likely to participate in a reuse system. There we go. So Perpetual's role in the process. We're really bringing together the local NGOs and the city and the local businesses to tell them about the program. We're bringing expertise. We actually have a team member that has operated a reusable system, mobilizing funding not just for ourselves, but also for our local partners and for infrastructure for the system, and providing on-the-ground support for training and launch. And sharing best practices, not just with our local partners, but also with other cities that are interested in bringing a reusable program to their city. We have local partners both at the city level and in our overall program. We have a partnership with the EPA's Trash-Free Waters, and we also have 3 academic partners. We have a partnership with the University of Georgia's New Materials Institute with their circularity assessment protocol, where they're actually measuring how waste moves through a city both before and after launch of our system. We have a partnership with the University of Chicago's Data Science Institute, which are helping us locate where to put the return bins and also the routing for transportation. And then we have a partnership with the University of Michigan, and they're doing a parametric life cycle assessment model for us. And that basically means that they've built a life cycle assessment model that they can change the parameters of, so we can give them the inputs of exactly how reuse would work in our city, and they can tell us the environmental benefits of the reuse system compared to a single-use item. And they're doing that for each of our 4 cities. Our project plan takes about a year, and we are in the design phase where each of our cities, although a little different place along the way. So our first city is Galveston, Texas. And we really thought Galveston really made a compelling case for reuse. It's geographically contained because it's an island. We've got a good, concentrations of businesses in a downtown area. There are lots of local organizations that really care about protecting Galveston. And then we also have the story of tourism, where they really see that having a cleaner city means more tourism dollars. And also the idea of being first for reuse is a really compelling story. So we had a series of workshops last month, earlier in March. And this was really a community design process. As Perpetual, we don't want to come in and tell a city what to do. We want to bring in members of the local community. And our partnership with Turtle Island Restoration Network, they helped us get the word out to have 3 community meetings. Plus, we had a meeting with NGOs, and we had a meeting with local businesses, as well as a series of one-on-one meetings. You can see some images from our series of community meetings that were held at Moody Gardens. And to get people to come out, we offered a meal stipend for everybody that attended. We also offered, for people that had the Lone Star card, we offered them a $40 cash stipend, because we really wanted people from every economic level to be able to participate in these meetings. And then we also offered childcare. So we found that people were overwhelmingly interested in participating in a reusable copper container program if it was in Galveston, which is great news. And then we asked some questions about whether people would want like a penalty model or a deposit model. And I think obviously the way the question was worded, people really wanted a rewards model. People really want rewards. But it's important to set up a model in a way that we get these items back, because from a life cycle assessment model, we don't want to make really fancy single-use items. That's not good for the planet. We need these reusable items to be used multiple times. But as we found from some of our other research, if you make these items too attractive, or you make them a tourist thing, it says Galveston in big letters on it, that means the people are likely to keep the items. So you want them to be nicer than the single-use items, but not so nice that people want to keep them. And, we also did a series of like open-ending questions with people, and we got some really great feedback. Like, people want the program to succeed. They want to help. They see it as an opportunity to like improve the community. They really think it could help Galveston and obviously the wildlife in Galveston. And they really wanted to see it in other parts of the country. We also had local business involvement. And this is an area where we want to do more focus, doing even more outreach from local businesses. But we did find that the businesses that participated in our meetings were really excited for reuse and saw how it could be beneficial for them and their customers. So our next steps, we're going to take all of our learnings from these meetings, plus learnings from talking to various reuse service providers and various corporates, so operators of fast food chains, to really figure out how to create a system of reuse that will work for Galveston. And once we have this plan, we're going to bring the plan back to local partners, local NGOs, and local businesses to have them help us refine the plan. And up here, you can see an example. This is a drawing of how we imagine a reuse city. So you could take out your coffee cup in the morning, drop it off outside your office park. It'll get clean, washed, and sanitized. And then for lunch, you could pick up an item in a reusable clamshell and then go sit and eat it at the park and drop it in a return bin. So this is just kind of a visual representation of what we think a reuse city could look like. And thank you everyone for your time. And please let me know if you have any questions. Also, the QR code up here will take you to our website, and you can sign up for our newsletter on the website there.
Questions for Christina right here. The question for those online is how clean do the containers need to be before you return them to the bins?
That's a great question. And actually what we found is some systems will actually ask people to rinse out the containers, but we found from life cycle assessment that it's actually better if they don't wash the bins because then you're not using more water. So what's more important in the process there is to have the bins emptied very frequently so you're not attracting pests, and also designing the bins in a way so that the pests can't get into them.
Any other questions? Go ahead. The question was, what would the cost be to build this infrastructure?
That's a great question. It's actually something that we're working on right now. And I've seen some email traffic between my colleagues today about, and it's something that we'll be including in our plan.
All right. Thank you so much, Christina. Okay, next up, we have Colleen Kavanaugh and Collie Hodges, and they'll be presenting on empowering the next generation of wildlife advocates.
Hey, everybody. How's it going? Y'all made it. 4:15, 4:20. It's awesome. Hang in there. Yep. I can't sing or dance, so we're going to need some slides at some point. Do you know any jokes, Colleen?
I feel like I should.
This is where you always have a joke in your back pocket. Okay, here we go. All right. So we're from the Houston Zoo. Happy to be here on the solutions track, talking about our efforts to reduce single-use plastics and in particular empowering some young environmentalists to help towards that effort. Let's see if this works. So I'm Collie Hodges, a sustainability manager for the Houston Zoo. Been with the zoo for about a year and a half.
I'm Colleen Kavanaugh. I'm the teen program supervisor, and I've been at the Houston Zoo for about 6.5 years.
So just real quick, in case you don't know about the Houston Zoo, we just celebrated our centennial, our 100-year anniversary last year. We see about 2.22-ish million visitors a year, which makes us the second most visited zoo in the country. You see we have wildlife saving partnerships across the world. And we're kind of a small city in a way here in the heart of Houston. And you see our mission up there in the upper right. Like all modern zoos, we are a conservation organization dedicated to saving wildlife. And, let's do this. So we want a moment to kind of acknowledge you all here. So how about anyone who came here with a reusable water bottle today? Can you stand up? All right. Very cool. Okay, stand up, good. All right, how about you stay standing if you use a reusable grocery, a reusable tote for your grocery shopping? All right, cool. Stay standing if you like skip a straw when you're at a restaurant. Okay, I think a few people sitting down. All good. Awesome. Well, okay, you can sit down. Yeah, very cool. Actually, everyone raise your hand. Okay. There was no reason for that. I was just drunk with power. Okay. Well, congratulate all of y'all for, having a wildlife saving action as a part of your life. That is the reason that we've taken these efforts related to single-use plastics is in order to save wildlife. As you all know from all the presentations today, single-use plastics often end up in bodies of water and harm wildlife. So here are some of our public facing efforts to do this. We actually don't sell single-use plastics on our campus, but we don't control what guests bring in. So we have campus-wide recycling efforts to ensure proper disposal of plastics. Our restaurants are single-use plastic free. All food is served on compostable plateware, and all beverages are sold in reusable or recyclable aluminum vessels. And in collaboration with our culinary and retail partner, SSA, who runs our gift shops and restaurants, we have over the years phased out plastic bags, plastic bottles, straws and lids, and most recently, single-use plastic packaging in all of our stores. So we're the first zoo in the United States to have done all that. Yeah. Thank you. As far as our staff kind of eccentric efforts, every year we have a Plastic Free July effort, which we've recently kind of renamed Sea Turtle Saving July. Would be curious to hear from other organizations about the nomenclature you all use for such efforts. We tend to like to associate our efforts with a particular species that you're saving. So we've kind of retitled it Plastic Free July to Sea Turtle Saving July. Really what we do here is we allow our departments and their local sustainability champions to really identify ways that they can curb, in particular, plastic use within their daily activities. And then we celebrate that through newsletters and kind of staff internal communication. Some of them organize cleanups. So that's kind of an internal effort that we do. Even some of our exhibits are reinforcing this message. This is a photo from our Galapagos Islands exhibit, which is opening to the public this Friday. It's going to be a one-of-a-kind exhibit. You should come by and check it out. It has its own area here dedicated to single-use plastics, this interpretive gallery where we've identified particular waste streams that we've phased out at the zoo, and they're displayed in these tubes. And all the media in this area, in this room, is really focused on how guests can curb their own use of single-use plastics. So again, one-of-a-kind exhibit, and unique to us that we have this embedded take action message within the exhibit. With that, I will hand off to Colleen.
Thank you, Carly. Hi, everybody. Again, I'm Colleen. I'm the Teen Program Supervisor. So in alignment with all of the organizational efforts that the zoo has made to reduce plastics across the zoo, we've also incorporated all of these efforts into our education programs. So as the Teen Program Supervisor, I run our teen program for kids ages 13 to 17 years old, which I know there are at least 2 people in this audience who were part of Zoo Crew when they were in high school. I'm going to call you out, Chloe. You were definitely one. And so with this program, we are really trying to cultivate the next generation of conservation heroes and empower them to find solutions and find ways that they can make changes in their everyday life to help save animals in the wild. And I forgot to mention the name of our education program is Zoo Crew. So I'm going to be calling these teens in our program Zoo Crew members or the Zoo Crew throughout this next couple of slides. So a lot of our participants have participated in our Sea Turtle Saving July efforts over the last several years, and especially our teens in our Teen Leadership Council, which are a smaller group of teens in the program who really are mentoring and leading their peers. Now, the Teen Leadership Council especially has been empowered to encourage and lead their peers to participate in Sea Turtle Saving July and to incorporate a lot of these plastic reduction efforts into their everyday life. So this past summer, part of Sea Turtle Saving July was that the teens had to conduct an audit, a plastic audit in their home to find out where they're using plastics the most and where they could potentially make a change to reduce their plastic usage. So in this first photo, you'll see Riley. Riley is making her public plastic reduction pledge. So after they did their audit, we encouraged them all to make a pledge to change one thing in their life that can reduce mostly single-use plastics, but really just any kind of plastic usage. Most of the teens did choose some sort of single-use plastic. Ziploc bags were the #1 choice, or to find alternatives or reusable alternatives to plastics that they might use in their everyday life. The next photo you'll see is Ava. Ava is showing off her handmade reusable t-shirt bag. Now, part of the Teen Leadership Council's duties for the summer were to lead conservation crafts. And these were easy DIY projects that teens could do to use or create alternatives to plastic usage items. So by showing them how to make their own reusable t-shirt bags, they could reduce the amount of plastic bags that they might use in their everyday life. And they led this by using our old Zoo Crew uniform shirts that had the old zoo branding. So these were t-shirts that we weren't going to be able to use anymore, and we're probably just going to go end up in a landfill, but we found an alternate use for them in creating these t-shirt bags. Now in this third photo, you'll see Herbert. Herbert is one of our members of the Teen Leadership Council. He is teaching his Zoo Crew peers how to make soap. Herbert makes his own soap. He and his family make their own soap out of natural items like seeds or loofah, which they grow in their backyard, as an alternative to microbeads, and they use those as exfoliants in their soap. So Herbert led one of his conservation crafts, showing his peers how to create their own soap. And he also was able to show off his soap making process on the zoo's Instagram during Sea Turtle Saving July. And he was challenging our social media followers to find their own DIY project that can help reduce plastics. Now, not only are our teens inspiring their peers, but they're also inspiring our staff. As part of Sea Turtle Saving July, the Houston Zoo puts on a plastic reduction open house. And this is something where our staff, either teams or departments or individuals, can show off the ways that they are reducing plastics in their everyday life or within their department at the zoo. So the Zoo Crew, the Teen Leadership Council members, were able to host their own table to show off how they inspire guests of the zoo through on-grounds interpretation. As you see, they have this jelly versus junk game that they will often do with guests on grounds to teach them about plastic reduction. But they also were able to show off the ways that they are reducing plastic in their personal lives. So Annie, who's one of our Teen Leadership Council members, she showed them how she creates her own reusable lunch containers out of handmade beeswax wraps. And not only are they inspiring guests, inspiring their peers, inspiring the staff of the zoo, but they're actually taking action to remove these threats from the habitats where animals live. So throughout the summer, we took groups of teens to Surfside Beach to participate in a beach cleanup. And they were gathering trash and also sorting it, weighing it, and then recording that data. And we collected that data throughout the summer. So last summer, they collected 200 pounds of trash, 23 pounds of plastic, 21 pounds of aluminum, and 10 pounds of glass. And so they were able to remove these threats to help protect animals like sea turtles. Now, the Houston Zoo also supports a teen environmental organization in the Galapagos, which is in alignment with our new Galapagos exhibit. And so this club, called the Mola Mola Club, we had a friendly competition with them over the summer to see who could collect the most trash from the beaches, either the Zoo Crew or the Mola Mola Club teens. And it was a way to just show that we are all taking action across the world. What we do in Texas, it impacts what happens in the Galapagos. And so we wanted to show that it's a team effort, that teens across the world are taking action to protect wildlife. And doing these beach cleanups, we're helping to save green sea turtles, which call the Texas beaches, as well as the Galapagos beaches home. Now this summer, we are going to continue to do these beach cleanups, but we are adding in a new part of it. We're going to be doing the Nurdle Patrol surveys as well. So we're going to be able to add that data to Nurdle Patrol's database. And now that I've heard about the Texas litter database, I also want to be able to put that data into that database as well. So I'm learning a lot today, and I'm hoping to incorporate a lot of what I've heard in these presentations today into what our program is doing at the Houston Zoo. So the efforts that these teens are doing to inspire the guests of the zoo, their peers, our staff, and to actually take action on Texas beaches to reduce threats to wildlife is saving animals like the sea turtles. And so we want you to join the teens in these efforts and join us in Sea Turtle Saving July. If you scan this QR code, it will take you to a survey where you can give your name, your organization, and your contact information, and to tell us that you are committing to participating in Sea Turtle Saving July. We'll be sending some follow-up emails with some information and some reminders about Sea Turtle Saving July, as well as some tips on how you can get started in your plastic reduction efforts in your life. So please join us. We talked to the Houston Botanic Gardens today, and they are excited about participating in this, and we're hoping to get a collaborative of organizations across Houston to join us in Sea Turtle Saving July. So please send us your contact information so we can see who all is going to participate. And with that, questions?
Thank you so much. One question. right, I'm not seeing any. Oh, one question. Okay, go ahead.
Yeah, thank you so much for that. So yeah, that's part of the Sea Turtle Saving July. What was formerly known as Plastic Free July is that a lot of the different departments in the zoo found the ways that they could reduce plastic in the operations of their department. So I know our children's zoo especially, they are using all reusable containers for their animals' food, whether that be, pellet food or meat or whatnot. And so they found a system and a process of being able to give those reusable containers to our animal nutrition department. They prepare all the food, give it to the children's zoo, they use it, they wash it, they give it back to the animal nutrition department so that we don't have to be using those single-use plastic items. Yeah.
And just to add to that, it's a great opportunity to try to like pilot a sustainability effort or a plastic, reduction effort for July. And then often we see it sticking around, but that's, part of the advantage to isolating it to a month and giving it, kind of this challenge around it. But a lot of it we see sticks around, becomes permanent.
All right. I'm not seeing our next presenter. We'll go ahead and take this question right here. Go ahead.
Yeah, for the Zoo Crew program. Is this my Dickinson High School group up there? Yes, I was just gonna say, I better be recruiting you guys. So Zoo Crew is the first year is a 4-week commitment in the summer. We do have an application and interview process that you have to go through. The applications open in January and then they close in March. So unfortunately, you've missed the deadline for this year, but next year. And then there's interviews in April, and then the program starts in end of May or beginning of June. But if you want more information, go on the Houston Zoo's website. There's a lot of information about the program. There's also an informational video. We did an information session in January, and that recording is on there. So if you're interested, and all of you did a wonderful job on your presentation, so I would love to recruit you for Zoo Crew. If you're interested in it, go on the website or email us. teenprograms@houstonzoo.org is the best way to get in contact with us.
All right. Thank you, guys.
Thank you.
Oh, you're here. Okay. All right, this is the last presentation. We have Son Win, spreading the world on Nerdle Patrol, leveraging technology to raise awareness and mobilize action.
All right. Right. Okay. All right. Hi, everyone. Last person, so much pressure. All right. So nowadays, no matter where we go, anywhere we see, and then literally every one of us has a smartphone, a tablet, or a computer, right? So with these device, will allow us to access tons of informations, create networks on files, expanding networks, and also we are able to collaborate and share with many people who we've never spoken with, never met, but we share the same cause and follow the same passions. And I'm sure all of us here has the same cares about the same thing, fighting plastic pollutions. And our works over the couple of recent years is leverage the wonderful technology called the internet and the web to collect data, leveraging technology to raise awareness and mobilize actions, right? And thanks for the collaborations with the Mission Aransas Reserve from the University of Texas Mission Marine Science Institute and the Mariota Bay Mitigations Trust. To start, just a little bit about myself. I'm I am the Assistant Director of the Analytic and Technology Solutions at the Conrad Luce Institute, located at Texas A&M University, Corpus Christi. I manage software development projects, and we work on the Neural Patrol website and the mobile apps. So if you submit the data, thank you so much. And for Colleen who mentioned that you are going to submit the data on Neural Patrol, it warms my heart. And for those of you who are wondering why is there an IT guy here? Well, I'm not here to telling you to turn your device off and on again if it doesn't work. So you'll be fine. So a little bit about where it works. The Conrad Luce Institute was located in the beautiful island campus at Texas A&M University, Corpus Christi. We were founded in 1987, and we have currently we have around 70 or 80 staff, affiliate, faculty, and student researchers. Our works, one of the most recent significant work is we got award by the NSF AI Artificial Intelligence Institute, working on AI trustworthy for environmental science in general. And just to be sure, we guarantee we're not building a Skynet. Wink, wink. So, and we are, so the division where leads is the CBI Analytics and Technology Solutions. We call our CATS. I'm getting ahead of myself, actually. The NSF AI CCU, we works with multiple University of Oklahoma, North Carolina State, Colorado State University, University of Washington, and University of Albany. Also, we have private collaborators. We work with Google, NVIDIA, and IBM. For the CATS divisions, which I lead, we build software and solutions that, and also we have a few operations crews who go around, in contrast to us, just staying in the room for the whole day. They are out of the field the whole week, installing and maintaining the coastal monitoring systems. So from them, we collect data, and then for the CATS division, we use those data, we build database, we use scalable system, and we serve this researcher and the student for the AI institutes. They use those data to create artificial intelligent machine learning models, help with environmental science costs. So now come back to Neural Patrols. So the story beginning in 2018, when Jace Tunnels was exploring the collaborations with the Conrad Luce Institute, and we initially want to build a website, a database where the citizen scientists will be able to document their on the survey trips about neurals. And it's 2023 now, 5 years later, we have tons of works done. And some of them, you can see here is a roadmap. From this size, you can see we initially just build a page where you can submit the report, this data where there you can see that. And we do verify QA, QC here, so the admin staff can go in and check if the data correct, right? So good neural, bad neurals. I'm kidding, all neurals are bad. So, and yeah, and then we collect data. Now what we do statistics and map. So if you ever go to the Neural Patrol website, you see the maps with lots of data collected there. And we build all those tools on the top for the admins to add more content into the page, generate new reports. And most recently, we have the Spanish language translation for the whole Neural website. For the bottom here, you can also generate your own report on the maps. We developed recently, we developed a tools where you can just select an areas where you want to show all the data that we ever collect in the system, and it will generate a simple report for you. Also, we developed the Android mobile apps and iOS mobile apps, so it's easier for you to go on the field with limited access to the internet. You just submitted the data you collected right away. And here's some of screenshot of what we have here. You can see the mobile apps on the Google Store and the App Store, Apple App Store, and here's the website. Here's the map that you may have seen before. Surprising, every time I see the maps, and initially we want to collect data around Gulf of Mexico, right? And then we see data coming from North America, South America, Africa, Europe, Asia, Australia. And the bottom right here, you see an article in Spanish. That's our most recent work. And here's Neural Patrol's website and the mobile app ecosystem in some numbers. So we have over 500 downloads on Apple and Android, actually. And over the last 12 months, we have on the website, we have 60,000 visits, 16,000 surveys so far recorded in the system, and more than 2 million neurals collected. And what's next for us now? Now that we have the data, we have statistics. Now, what's going to be our next goal? So maybe we should do a wash up beach dolls patrols. How about that, Jace? Well, this is a reference to Jay's features on John Oliver's show last year. Highly recommended. So new ideas. So in a world where we see the attention span of us last 30 seconds to a minute now, every information we see and we read should supposed to be bite-sized, and then we don't have much time. We're just gonna read something and okay, I learned something, and now we're done. We're moving to the next thing. So whenever I looked at the NeuroHunt or UK Hunt poster here, it's very informative. But how about we make this more, interactive, things moving here, and it's easier for you to see and then just to grab. Okay, I looked at an animated interactives where I know where the neural was made and where it's built up, and then where we can collect the neurals. So with this content, we are targeting a younger audience, where I think it's a very good tool where we can spread the words easier. And of course, everybody likes numbers and charts and graphs, so statistics and visualizations. And one of the things that is not original on these presentations, but I've seen so many fantastic things in the mornings and in the afternoon as well. But one of the things that when we collect data, I've seen that questions, not a question, but the struggles being repeated over and over again, which is, okay, how we spend so much time looking at this and countings. How am I going to use that? We spend so much time doing that. Maybe we're going to use some artificial intelligence here. I mean, how cool is that? If you submit a photos and it will count how many items you have, how many neurals you have in that photos. So you have to go over and count 100 or 200 of them, right? So we are really interested to hear your feedback. Your collaborations would be awesome. If we can just use collaborate, anything is possible. So here's a QR code to download for neural mobile apps for iOS and for Android. So let's download and collect some neurals. And here's my information. Thank you, everyone.
Any questions? Nice, they're letting you off easy.
Yep.
Thank you so much. All right, guys, you made it. So now we are going to have presentation of the student awards by the Coastal Bend Bays and Estuaries programs. We have Quinn Hendrick, and I just want to say thank you to them for providing these awards. It's really, really appreciated.
All right, let's give away some money. So first of all, let's give another round of applause for everybody today. I know personally I learned a lot. And as we were totaling up these scores, it became clear really quickly that it was a tight race. So again, good job by everybody involved, but we'll start with the poster presentations here. So third place on the poster presentations on the project of artificial weathering of laboratory generated microplastic particles towards defining reference materials, Taiwo. We're here. Feel free to come on down if you'd like. I've got a gift card for you. And so in second place on the poster presentations, Rigoberto Carmona in bioprospecting the gut microbiome of Zophobas moria, the search for plastic degrading microbes. All righty, and last but not least, first place of the poster presentations, we have Glorabel Carmona on selective culture and sequencing of polystyrene degrading microbes from the gut of superworm, Zophobas moria. All righty, winners, if you guys want to come on, come up here. And so now we will get into the presentations again. A lot of great presentations, a lot of work, inspiring by the youth that's getting involved in the work that's being done there. So third place for our presentations is estimating abundance of microplastics in the surface waters of the Galveston Bay watershed by Emily Cox. And in second place, the photo degradation patterns differ among different types of plastics after long-term UV exposure. Tao Tao, we here. All righty, and so first place for our presentations today, the presentation on microplastics and solid waste study on marine and coastal ecosystems in Mexico. Ana Hernandez Soriano, come on down. All right, let's give another extended applause for these guys and all the hard work put into it. All right, you guys want to get a quick picture of work? All righty, yeah, if you guys want to come over here, I'll get you your money. And here, we'll do this off stage, actually.
Well done.
All right, one more round of applause for him before we get out of here. Thank you, everybody, for hanging out until 5. Stay dry on the way home. Be safe, and we'll see you guys next year.
I got to say one more thing, we have till 5. I'm going to be up here for the full 5. No, I'm kidding. I just have a few things. One of the most important things is that this is the best, or I'd say this is the most people that's ever been here. And I think the best that that we've ever had. for this symposium. And so I want to thank Lisa and Matt for everything that y'all had done to make this happen. When Lisa had said that she was willing to take this on and have it up in Houston, I said, go for it. You know, I was really excited about that. And all the organizations you were able to bring together for the committee is huge. All these organizations that are on here, I just want to thank y'all for that. It's big. Logistics for putting something like this on can be difficult and challenging, but it all came together today very smoothly. So I just want to thank y'all for that. For next year, we're going to host this thing again. And so we don't have a particular location in mind. So if there's somebody out there that's would like to be able to host this in your town, your city, think about it, get a hold of me in the next 6 months and we'll start planning. But thanks everybody for coming out. What you do matters. The research you do, the monitoring, the education, the advocacy, and the policy that's coming out from the work that you're doing really does make a difference. And so appreciate everybody coming and we'll see you next year. Thank you.